Hello, my dear J warriors. Welcome to the next class of your roar series. All the lions are welcome to this particular class because we're going to cover not only the concepts but also the questions with the PYQs as much as possible in the three levels: level 1, level 2, level 3 questions with the PDF, with the notes, everything. So I hope you are all excited, and in fact as excited as you were before for the first lecture. Are you ready to conquer this? My dear students, hello Pratap, Sriram, Dharanishwaram, hello Lafi, hello Adiksha, hello everyone. Good evening. So let's begin with the lecture. We are going to do complete vectors today, and all of this with your captain Shreyas Sir. We have to prepare for JE25, JE26. Remember, 25, the first mains paper is just, probably 6 to 7 months away maximum. So make sure you are up to the speed, up to the mark. Do not miss any class. Every one class missed is one extra backlog created. And we have a lot of chapters to cover, and we are going to do it in detail on this channel. Okay, so let's begin. Hello Adiksha, hello Seven, hello Leon, hello everyone, hello Heji Bhaiya, hello Ronaldo Su. Nice to see all of you. Nice to see all the new names, because these are the names I'm pretty sure I'll be seeing on the not just the leaderboards but also our result sheet, which is going to be published next year, right? So let's begin. Thank you for liking and subscribing. If you have not yet done that, please do that. That's your Guru Dakshina for attending these classes on YouTube. So let's begin with vectors, and some of you already know something called as magnitude and something called as direction. Like, before joining a YouTube channel or any coaching, probably they say that you are a scaler, and once you find the right mentor on YouTube or on any platform you are in a coaching, then you become a vector. Meaning, before joining, you just had some value, you did not have the direction, you had that magnitude in you, you had that value in you, but just that you needed to channelize it in the right direction. So that's when you become a vector. So my dear students, ready to become vectors, hopefully in the next couple of months with the right direction. True. So physical quantities, if you remember, physical quantity is something which can be measured, like temperature, it can be measured. Happiness, I can't measure. I'm very happy. Okay, fine, great. I can't measure it on a scale, 78 happiness, 20 happiness, no. And remember, we had categorized physical quantities into two separate categories in units and dimensions, which was basically fundamental, derived, and all of that. In this chapter, we are categorizing it into two different quantities like this. One is scalar, one is vector. One is scalar, one is vector. What are scalar quantities? Scalar quantities are basically the ones basically which which don't need which don't need direction don't need direction for their description for their description. Not just that, you will see later on, you will just see later on that they don't they don't obey the rules of vector addition. They don't obey the rules of vector addition or basically subtraction. These are the two main things which you should know about scalar quantities. Their direction has no meaning, and also they do not obey the rules which you will learn later on for vectors being added or being subtracted. Let me give you a simple, easy peasy example. If I ask Pandu's 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 top speed, what is Pandu's top speed? And Pandu replies, the answer is 50 kilometers per hour in north direction. You will be surprised. Why is Pandu saying 50 kilometers per north, 50 kilometers per hour in the north direction? What is so special about north? If you can travel 50 kilometers per hour in the north, you can go in east, you can go in west, southeast, anywhere. So this north has no meaning. This north has no meaning over there. So guys, Pandu's top speed is a scalar quantity. Pandu's top speed is a scalar quantity. Agree with this? Yep, very nice. Similarly, another quantity which you can categorize as scalar quantity is, if I ask, what is Champa's mass? What is Champa's mass? And Champa replies, the answer is, Champa's mass is 60 kg. Champa's mass is 60 kg. Will you ask Champa, your mass is 60 kg in east or in up or in down? Champa will give you one tight slap. What do you mean? East, west, down. So there is no meaning of direction. There is no need of direction for the description. Agree with this? Yeah? All right. I hope this is very clear. Sir, you was the institutional physics teacher I ever met. Can you see gate physics? Oh, gate physics. Maybe not yet. Maybe someday. Okay. Not yet. For now, 11th and 12th standard. All right. So, a scalar quantity is completely described by magnitude alone, no need of direction. It is just described by a number 50 kg, 70 kg, 50 meters, 29 seconds. All these are basically pure numbers without any information of the direction, speed, volume, mass, temperature, power, energy, time, all these current, all these are scalar quantities. When you learn new chapters, you will understand why it is a scalar even better. Like even if I say power is a scalar, you will be like, yes, sir, power is a scalar. But you will realize sooner or later when we come to work energy chapter, why is it a scalar? Even better. Okay. Same thing about current also. When we come to the current electricity chapter, you'll be like, yeah, I now know why current is a scalar completely. You might get 90% convincing power right now, but 100% will come once we see those terms in the respective chapters of 11th or 12th standard. Okay. Similarly, what is vector? Vector are those quantities which have, yep, come on guys, concentrate on the lecture in the chat box. Okay. Sir, north is unit or not? No, north is not a unit. North is a direction. Who is that JEE aspirant? Yep, north is just a direction, not a unit. How can it be a unit? Okay. Vector quantity, you will need both. You will need both magnitude and direction for its description. For its description. Obviously, it's a vector quantity, so it follows the rules of vector addition. We'll see what that is later on. Vector addition or vector subtraction. One of the best examples of vectors can be force. Pandu pushes the box with how much force? With how much force? Now this force has been defined to be a vector quantity because it obeys both these things. It is found to follow the rules. Also, you need both magnitude and the direction for its description. So Pandu's force, I can say maybe it is 35 Newton in the west direction. Pandu is pushing the box with 35 Newton force in the west direction. So force that becomes a vector quantity. Good evening, Vanilla. Yeah. Similarly, many more examples are there. Many more examples are there. Like I can say, what is the momentum? What is the momentum of Champa who is running? Of the Champa who is running? Then the answer could be the momentum of Champa is 20 kg meter per second towards the school maybe. I'm specifying direction, I know which school I'm talking about. So it is a vector quantity. Is that right? Yeah. So you will see that later on that area is actually a vector quantity, but in most cases we also use it like scalars when not required to be treated like vectors. In 12th standard, Aditya, you will see area can be taken as a vector quantity in Gauss's law chapter. Okay, fair enough. So it needs magnitude, it needs direction, it follows both the laws of addition, subtraction, laws of vector addition, subtraction, right? Force, velocity, acceleration, displacement, momentum. You will see all these are field, weight, okay? All these are vector quantities. Till this point, everybody clear? Give me a thumbs up. Till this point, everybody clear? Give me a thumbs up. Yep, everyone clear? Awesome, awesomeness. So now that you have understood it till this point, let's see how do we exactly represent any vector quantity. It's very simple. Let's keep this very quick. You might have already learned this in 9th grade, but still a quick revision. If you want to show any vector mathematically, you put that symbol and you put a bar or an arrow mark. That means it's a vector. If you want to show it diagrammatically, then you show it with a tail and the arrow mark head over here. The one which does not have that arrow is called as the tail. The one which has the arrow is called as the head. The length of this is the magnitude, and the direction in which it points is the direction of the vector. If you put a arrow mark, but if you put these two bars, vertical bars, which is called as the modulus, it means you are talking about the magnitude of the vector. You are talking about the magnitude of the vector, meaning purely the length of the vector. Let me give you an example of this. Imagine I tell you Pandu's velocity v bar. You can also put v with this arrow mark is equal to 70 kilometers per hour in the northeast direction. Because I have put bar, it is a vector. I have given, you can see over here, I have given this is nothing but the magnitude information, and this part is nothing but the directional information, both. But let's say, for example, if I put V bar modulus or this V arrow mark modulus, I am interested only in the magnitude part. I need not have to give the direction. So I just will write 70 kilometers per hour. That's it. Only magnitude information is given to me. Only magnitude information is given to me. Lot of people also think, oh, this arrow mark shows the direction. Actually, not literally, it shows a representation. See, a lot of you might think, sir, this is north, this is east, this is west, this is south. Sir, the velocity is in the northeast, so should I draw like this? Sir, the velocity was in the west, should I write like this? Sir, velocity was south, should I write like this? No, it does not mean literally. It's just saying there is some direction inside that particular term. Some information is there. That's all it is representing. It is not actually showing the direction. It is not actually showing the direction. Till this point, is it clear? Everybody with me? Okay. If you had to show it, if you had to show this particular thing in the diagrammatical form, then I would have shown like this. I would have shown like this with probably a small scale over here. This is north, this is east, this is west, this is south. You can see it is pointing in the northeast direction. And yes, of course, the length of this would have been 70. The length of this would have been 70 kilometers per hour. The length of this, which is also the magnitude, would be 70, just like I mentioned right over here. This length is the magnitude of that particular vector quantity. Is that right, everyone? Very good. Okay. Now, moving on. Now that we have learned how do we mathematically represent a particular vector as well as its magnitude, let's also see the different types of vector. Yep. Something which is very simple, just that you should know, because sometimes they might use a word. There is a unit vector here. These two vectors are parallel. These two vectors are negative of each other. So in a big problem, you might have one word which describes how the vector is. So when the description comes, you should know what we are talking about. Nobody in JEE will give you a solo question, identify the type of vector. That will never ever come. Okay. So what are the different types of vector commonly used in our day-to-day problems of physics or maths? One is zero vector, or basically null vector. Now, the meaning of this zero vector is basically the magnitude is zero. The magnitude is basically a zero. And what is the direction? This is the only vector. The direction is not defined. The direction is not defined. Very, very important, guys. And I'll put a star mark. This is the only vector. This is the only vector whose direction is not defined. Any other vector You need to tell me the direction. Because if I tell you there was a donkey who did not move the whole day, the donkey was stationary. What is the velocity of the donkey? You will say 0, because velocity is a vector. That's why, I will say 0, but direction is not there. Because if I'm not moved, how can I say 0 kilometers per hour in the north or in the west or in the up or in the down direction? There is no meaning of the direction. So that's why 0 vector has no significance direction wise. Yeah, I hope this is very, very clear. Yep. Aditya, you will be learning about how area is a vector quantity in 12th standard in a chapter called as Gauss's law, where we'll be dealing with area as a vector quantity when we see the term called as electric flux. Okay. So for now, I would leave it, because if you are 11th student, it's okay. If you are a 12th, hold on. Anyways, this week I'm starting electrostatics. By next week, you will be reaching Gauss's law. All right. Okay, okay, all right. So, Heroic, there will be DPPs uploaded, plus I'll be recommending some books which you can follow. I'll make a separate video on which books you can use, okay? We'll be making a separate video. So, zero vector, the magnitude itself is not there. I mean, it's zero, direction is not defined. Unit vector, like the name suggests, unit means basically the magnitude is 1. The magnitude is 1, and direction can be anything. Direction can be anything, doesn't matter. The direction can be basically anything. The main thing is that magnitude should be 1. Now, one of the example is, let's say, if p vector, if I put modulus and if it is 1, then it implies that p vector is an unit vector, Now, every time putting modulus and putting 1 is a tedious process. So there is a shorthand notation. Just like when you have to show any vector quantity, you put a bar or an arrow mark. So if there is a unit vector, there is a short way of writing it, and it is as follows. If you put A without the bar, instead you put a cap. Instead you put a cap on it, a hat. Hat also you can use, or cap, one on the same thing. Any word you want, you can use. Then it means that A hat is always an unit vector. Is always an unit vector. This only if it is 1, then it is unit vector, but A hat is always an unit vector. So therefore, it automatically implies if somebody decides to take the modulus of it, it will always be 1. It will always be 1. But this may or may not be 1. Only when, that's why I'll put over here, if P's magnitude is 1, only then it is unit vector. But here it is always going to be unit vector only and only if you put that cap symbol or the hat symbol. Yep. Yes. Any word that you want, you can use. Perfecto. Next important thing is the different special unit vectors. Like I said, unit vectors can be in any direction, north, east, west, south, up, down, forward, backward, anywhere. But there are special unit vectors. They are called I cap, j cap, and k cap. They are specifically aligned in the x direction, y direction, and z direction. The one in the x direction is called I cap. The one in the y direction is called j cap. The one in the z direction is also called as k cap. So these are nothing but your special unit vectors. Special unit vectors. Special unit vectors along the axis. Sometimes even I cap is also called as x cap. Sometimes j cap is also called as y hat or y cap, and sometimes basically your k cap is also called as z cap or z hat. This is perfectly okay. There is no harm in this. Yep. These are special unit vectors which have been defined, I, j, and k along the x, y, z axis. Position vector. Very simple. If this is my coordinate system, x, y, z axis, and let's say we find that there is a beautiful champa over here, and Pandu, standing at the origin, is looking at the champa. So Pandu is looking at Champa's position. So what will Pandu say? Champa is located here. So this is the position vector of Champa. Usually the symbol for position vector is R. R, position vector. It's the position location of Champa. If Champa moves like a ghost, then even the position will move along with that Champa. If Champa is here, position will be here. If Champa goes far, position vector will become long. If Champa comes close, position will become small. Okay, so wherever the Champa goes, that position vector will follow. So R bar is basically the position vector. Okay, everyone with me? Understood till this point? Right, perfect. Next important thing, position vector, if it is done, parallel and anti-parallel vectors, the name only tells you everything. If the two vectors are parallel, that means the directions are same. If A and B vector are parallel, A vector parallel to B vector, then obviously the directions are same. That's when the two vectors are parallel to each other. Magnitude may or may not be same, doesn't matter. If it is anti-parallel, then one vector is like this, one vector is like this, then definitely I would say that their directions are opposite. Directions are opposite. Opposite. And in such a case, A vector is anti parallel to B vector. And the most important thing which many people do not know or forget is if two vectors are like this, they are neither parallel, that is same direction, nor they are anti-parallel, that means opposite direction, then they are just said to be not parallel. Not parallel is not the same as anti-parallel. Be very careful about it. Okay, be very careful about it. Parallel, anti-parallel, not parallel. Oh, by the way, you will be getting the complete notes, Sasi, complete notes in our jungle book. So there is a link in the description box, that jungle book. Okay, that entire PDF will be available to all of you. Till this point, everybody clear? Awesome. So moving on to something called as co-planar vectors. Imagine I take a plane. Imagine I take a plane like this. Now this is a plane. Okay, this is a plane. If I put some vectors on this particular plane, if I put these vectors on this plane, then all these vectors are in the same plane. That plane can be in any direction, in any orientation. But if the vectors are in that plane, then it is coplanar. But if one vector is somewhere outside of that plane, or piercing through the plane or making some angle, then they are not coplanar in that same plane. Correct? So vectors are said to be coplanar if they contain the same plane. Like this one, they are in the same plane. Maybe if I show one vector which is probably like this, it is definitely not coplanar. It is definitely not coplanar. Very straightforward. Collinear, linear, line. That means along the same line. For example, this vector, this vector, this vector. They are all collinear vectors. They are along the same line. But if you see this vector and let's say this vector, 100% they are not collinear. They are not collinear because they are not along the same line. All these vectors are along the same line. Here it is not along the same line. As simple as that. Okay. All right. So today in my school they taught this. Wow, very good, others. So good revision, and we are going to go to much more level. Equal vectors. See, this is very, very important. Imagine there is one vector like this, another vector like this. Both are having the same direction and same length. So if A bar's magnitude is equal to B bar's magnitude and direction is basically same, they are said to be equal vectors. Therefore, A vector is the same as B vector. A vector is same as the B vector or C vector if more such vectors are there of the same length and same direction. So direction should be same and the magnitude should also be the same. Okay, so then they are said to be equal vectors. If direction is different, even if the length is same, they are said to be unequal. If direction is same, magnitudes are not same, still they are unequal. So both when they are same, only they are said to be equal vectors. Next thing, Next thing which is very important, is basically the negative of a vector. The meaning of a negative of a vector is, if I have a vector, let's say for example a bar, then the negative of that is the same vector in the opposite direction, something like this. So this is minus a bar, but of the same length. So minus a bar's modulus or magnitude will be the same as the length of this particular vector. So a vector is said to be the negative of a vector if the magnitude is same but direction is opposite. So I can just say it is opposite in direction, opposite in direction, of same magnitude. Okay, so that is the meaning of negative of a vector. Till this point, if everybody is clear, give me a thumbs up. Let's just quickly go through all the things that we have gone through. Okay, let's do a quick recap, my dear students. Null vector means no magnitude, zero, completely zero, nothing doing with the direction. Okay, unit vector means the magnitude is 1, and if you want to avoid this long conversation, you put a cap, then the vector becomes a unit vector if you put a cap or a hat. Special unit vectors are ijk. Next one is position vector, which basically points to the current location of an object or a particle. Parallel is when the directions are same, anti-parallel when opposite, not parallel means they are literally not parallel. Co-planar means same plane, collinear means same line, equal vectors means same direction and length or magnitude, and you will also see negative means same magnitude but opposite in direction. Okay, I hope this is clear. Very good. Yep. Sir, vectors you are saying, can you be more precise meaning? Yep. All right. Yes, Dushan, what was your doubt? You can definitely tell me. Sanjana will be having a question solving very soon. Hold on. Once this is done. Angle between two vectors, which is very, very misunderstood concept. See, if you have one vector here and let's say another vector over here, and you want to find the angle between the two vectors, what you will do is combine them together. Either their tails should join or their heads should meet at the same place. Either arrange it head or tail. Can you see that, everyone? Either like this, where their heads are meeting, or their tails together. Then this particular angle or even this particular angle is the correct angle between the two vectors. Now please understand this very important concept, that imagine you had a vector like this, or this same diagram. B vector is here and A vector, let's say I put it over here. Lot of you will be like, sir, why can't we take this as the angle? Then there will be confusion. I mean, should I take this as the correct angle? Or if I extend this line, this is also an angle. Why can't this be the angle? So to avoid that confusion, we have made a system. Always we are going to stick with that system. So when the tail and the head coincide, never ever measure the angle. That is not the correct angle. In fact, remember, when the head and the tail come together, had you just moved this vector B over here, then both their tails would have coincided, and then this would have been the correct angle theta. Actually, the angle which you measure over here will be 180 minus theta, which is not the correct angle. The correct angle would be over here. Okay, so either their tails should be together or their heads should be together. But if the head is coinciding with the tail, then the angle measured will be wrong. So slide it till their tails are together. Okay, slide it till the tails are together. Is this point clear, everyone? Okay. Confused Mars, this is JEE channel. We'll talk about it on the NEET channel, not here. Yep. It's not about smaller angle. No, it's not smaller angle. It is just the angle which comes when the vectors are joined with tail together or head together. It could be small, it could be big. So don't keep it in your mind that it is always small. Now take the examples of these. That's why we have the level 1 question over here. This, and this. In each case, can you quickly post in the chat box what is the correct angle between the vectors? What is the correct angle between the vectors? Sriram, the target is September. We are targeting September. Reena, you will understand it with this particular example. You will understand it with this particular example. Observe now carefully. Observe now carefully. Do you see both the tails are already together? Both the tails are already together. So hence, whatever this particular angle is the correct angle. So the angle is actually 45 degrees. The angle is actually 45 degrees. Very good, everyone. Okay. Now, the next thing over here, do you see both their heads are coinciding together? Both their heads are actually coinciding together. So you don't have to worry about any other angle. So you will automatically measure this particular angle. So this is the correct angle, which is basically going to make it 150 degrees. 150 degrees. Let's look over here. Let's look over here. The problem is this is a head, the other vector's tail is there. So that is not the correct way of looking at it. I mean, if you look at it properly, this is A. Slide that B over here. Slide that B over here. It will go like that. And this was 145 degrees, which is definitely not the correct angle. 145 is definitely not the correct angle. Agree or disagree? Yes, very good. Why? Because the head is joining with the tail. So slide it till both the tails are together. Now this is the correct angle, which is going to be 35 degrees. So hence the correct angle between them is 35 degrees. Now is it very, very clear? Now is it very, very clear, everyone? Yeah, either heads are together or tails are together, you can measure the angle. If head and tail are together, slide them, only then the angle measurement will be correct. Only then the angle measurement will be correct. That's how it works. Okay, very good. I can give you one last example just so that you guys are confident about it. Let's say I make a triangle like this. This is A, this is B, and let's say this is C, or let's say this is C. Can you tell the angle between A and B? Can you tell the angle between B and C? Can you tell the angle between A and C? Let's see if you can figure this out. The angles between each pair of the vectors. First of all, A and B. Check this out. Assuming this is an equilateral triangle. I forgot to mention that. This is an equilateral triangle. This is an equilateral triangle. Okay. Come on. Figure this bit out. A and B, I can clearly notice this is the head, this is the tail of two vectors. So I have to arrange it properly. So actually speaking, if A is here, then B can be here. Basically have slid that A vector from here to here. Now this is the correct angle. Now this is the correct angle between them. Obviously this was 60. So naturally this will be 120. So 120 should be the correct angle. How many of you wrote that 120 degree? If you wrote 60, that is wrong. You will get -1. You will get -1, guys. Okay, be careful. Look at it. A's head is coinciding with B's tail. So what about B and C? I think B and C are already together. I mean, their heads are already together. Can you see that? This is B and this is C. Their heads are already together, 60. Yep. So this answer is already 60 degree, no doubt about it. What about A and C? What about A and C? You can see A is over here, C is over here. Their tails are already together. So I just have to make this angle measurement, which is 60 degree. So this is 60 degree. So 120, 60, 60 is the correct answer. Very good, Aditya. Krishnan? No, 60, 60, 60 is wrong. Right. Okay. So the difference between your school level teaching and this level teaching is that in your regular school, what happened is you never had arrow marks. You had sides. This, yes, used to be 60, 60, 60. You never had arrows. The moment arrows come, then the angle's definition changes. You have to use this particular definition when there is an arrow mark. When there is an arrow mark, you have to use this definition. Is that clear? When there is no arrow mark, then it doesn't really matter. Then it doesn't really matter. I hope this is very, very clear. Awesome, awesome. Moving on. Addition of vectors. So I hope everybody had fun solving these questions. Moving on to now the main two topics. One is basically addition, the next addition, subtraction, the next one is multiplication. That's what we are going to deal in this particular chapter. This chapter, expect it more like basic maths. In fact, if you open up any JEE mains or advanced questions, very rarely you will find a question on vectors alone. Advanced though, never, almost negligible. Okay, so the reason for that, because vectors is actually used in other chapters like Newton's laws, work power energy, finding the torque, or let's say angular momentum, or let's say, you know, Gauss's law, finding the dot product in flux, or magnetic force QE cross B. All these 12th and 11th standard last few topics, you will be seeing heavy usage of the vector operations. You are going to see the vector operations usage, and that is what you learn right from now. So some of you might feel, why are we doing this now? I did not find any PYQs as such in JEE Advanced, or in JEE Mains also very few PYQs will be there. So don't get scared, or don't treat this chapter useless. That is the most common mistake which 11th standard kids do. If you are a 12th standard student, you already know why this chapter is important. Is that right? Everyone? Everyone? Yep, very good. So if this much is clear, let's learn all the different vector operations. So basically, when we talk about vector operations, vector operations, first is addition. A subpart of it is subtraction. Subpart of it is basically subtraction. The next one is multiplication. Multiplication is what we are going to learn. And please understand, division is not defined. Division is not defined. You cannot divide vectors. Like, it is illegal. A bar divided by B bar is illegal. It is basically illegal in mathematics. It is not allowed, because understand, there is no need of division, or rather there is no quantity which is obtained using division of vectors and it can be defined properly. So that's the reason why we do not divide vectors. Multiplication is fine. Addition and subtraction are also fine. Why did I put subtraction below addition is because actually we'll see subtraction is nothing but addition with a negative quantity. Very soon you will learn what it means. And one of the simple way to tell you that, when I write 5 plus 2, you are adding two positive numbers which gives you 7. But when I add 5 with negative 2, it is going to give me 3. This is the same as 5 minus 2. You can see this is subtraction. This is basically subtraction. Here, this is addition. This is addition with a negative number. It is addition with a negative number. So that's why I said subtraction is actually addition but with a negative quantity. So basically you will see, if one person understands what addition is, that person can easily understand what vector subtraction is, because you can just put a negative sign before that. That's all. So vector subtraction is actually vector addition. You will learn that. Okay, I hope this is very clear. Yep. Nika, we will be learning current electricity in sequence, like we'll be starting electrostatics, then Gauss law, then current electricity, capacitors. That's how it's going to go. Okay, so it's going to go with the flow. I'm starting the 12th standard chapters this Friday. Cool. All right. Is NCERT enough for JEE mains and advanced to crack? Definitely not. You cannot crack even JEE mains using NCERT. No, not possible. Okay, right. Now, in addition of vectors, when we want to add vectors, let's say for example, it's like saying, there is a Pandu who is pushing by 20 Newton force. another Pandu is applying 30 Newton force. So if I combine their effects, if I combine their effects, if I join their effects, if I combine their effects together, I will get one single force, maybe of example 45 Newton. This is called as the resultant. This is called as the resultant. And this process of combining these vectors, that is called as adding, because I'm adding their effects, their magnitudes, their directions, everything taken into consideration. I find their net or finding their resultant or net. So that is the true meaning of addition. Now understand, very unique and interesting things can happen in addition of vectors. For example, see guys, in scalars, 2 plus 2 is 4. 2 plus 2 is 4, right? But in vectors, 2 plus 2 may be 4, may not be 4. I'll give you examples. Imagine you apply 2 Newton force and another person is also applying a 2 Newton force in the same direction. Then the net resultant force, won't the net resultant force be equal to 4 Newton? 2 Newton plus the 2 Newton in the same direction will give you 4 Newton. Everybody agrees with this? So here 2 Newton force plus that 2 Newton force exactly gave me how much? 4 Newton force. But imagine this. One person is pushing like this, another person is pushing like this. 2 Newton from here, 2 Newton from here. Then what will be the net? I mean, the box or the object will not move. The net force will be a big fat 0. Very interesting. So in this case, 2 Newton plus 2 Newton is technically giving me the answer as 0 Newton. Is giving me the answer as completely 0 Newton. There is one more case possible. In fact, many infinite such cases are possible. Like say, for example, I applied 2 Newton force here and other person applies 2 Newton force here. The result of them could be again another, the net force could be probably 3 Newton, 2 Newton, 4 Newton. So many cases are there. Maybe let's say it is 2 Newton. Imagine this is like an equilateral triangle. So in this case, 2 Newton plus 2 Newton is technically giving you again 2 Newton. And like that, so many infinite cases are possible. Infinite cases are possible. So this is vector addition, where the angle between the vectors decides the outcome, not just the magnitudes. In scalars, which we have learnt in school level, 2 plus 2 is 4. Yep, perfectly fine. 1 plus 9 is 10, perfectly fine. But in vectors, 3 plus 3 can be 0 also, 3 plus 3 can be 6 also, 3 plus 3 can be 4 also. So many possibilities are there. So many possibilities are there. Yep. So that arrow mark is not implying direction. It implies that it is vector. It has a direction is what it says. What is the direction? Well, that you need to see the diagram or the description. Yeah. Okay. I hope this is clear. Dushyant, NCERT is not enough for NEET. Okay. You need to go beyond NCERT. Okay. So please do not just go with NCERT. That is not enough. It's necessary, but not sufficient. Okay. So some people say that NCERT is enough. That is not true. They lie. Now there are multiple ways of adding the vectors. So I made a beautiful flowchart for it. One is called as the triangle law. The second is called as the parallelogram law. And the last one is called as the polygon law. This is geometrical or graphical way. Okay, we'll see all these things. The next one is analytical way, where formula is given. And in that formula, if you put the values, zoop, you'll get the answer. Third way is in terms of IJK. Remember IJK? The special unit vectors, rectangular components. Exactly. So using those components, you can get, the resultant vector. So we're going to see how to use all these techniques to find the resultant, to find the net of the three vectors. Okay. So let's try to find that out. And the first one which we are going to focus on, is basically geometrical way or the graphical way. Yes, heroic. That's the reason why we are conducting these classes for mains and advanced only. So we cover all the chapters. We start with problem practice. We start with mock tests. We start with revision so that you are prepared for mains and advanced. And so many students even this year have cracked JEE mains with 99 plus percentile and even JEE advanced from this channel. And I'm so happy about it. Okay. So let's start with the three different ways of geometrical ways of adding the vectors. First one is triangle law. Second one, like I said, is parallelogram law. The third one is called as a polygon law. Like the name suggests, triangle means make a triangle. Parallelogram means make a parallelogram. Polygon means make a polygon. So something has got to do with the shape of that figure. So in triangle law, what happens? You have two vectors, you have to add them. You join them such that it forms the missing side. Sorry, it forms a triangle with a missing side. You have two vectors which you have to add. You join them such that it forms a triangle but with a missing side. The missing side becomes the resultant. As simple as that. But when you join the vectors, ensure that the tail meets the head or the head meets the tail. Not like before where I had found an angle. Remember, for angle, what did I say? For angle, what did I say? Tails or heads should be together. That is completely different story. Now we are talking about something else only. For triangle law, ensure the tail meets the head. Tail meets the head. I have shown one animation. I think it is there over here. Oh, the animation won't work over here. Anyways, I'll just show it to you like this. Imagine this is vector A. Imagine this is basically vector B. I want to add them. What you can do is move them till the head and the tails coincide. So let's say one way is this is A. B, you move it and put it over here. B, you move it and put it over here like this. Or keep the vector B as it is. Keep that vector B as it is. And take that A and put it over here. Take that A and put it over here like this. It forms a triangle but with a missing side. I hope you see that there is a missing side over here. I hope you see there is a missing side over here. Everybody? So that is the resultant, guys. That is the resultant. I think I'm not drawn it to scale. So that's the reason why it is looking like this. But if I draw it to scale, everything will be fine. Like for example, this is B. This is B. This is your A. So the missing side. So the missing side is basically this one or even this one. But now when I show the missing side, I need to put the right arrow mark. If I miss the arrow mark, I'm gone. So this was the tail, this was the head. Go exactly the same way from the tail to the head. So the right arrow mark will be like this, from the tail to the head. Same way here, this is the tail, this is the head of that orange things. So the tail will be here and the head will be here. So this is how you write it down. Here I took A first and then B. So this I can write it as A plus B. Here I took B first and then A. So this is B plus A. Whatever you do, you will get the same thing. It doesn't really matter. So technically speaking, A plus B or B plus A is one and the same thing. So this particular property is called as commutative property. What is it called? Commutative property. A plus B and B plus A both are going to be the same. Both are going to be the same. Correct. So what you need to do? Just slide them. Just slide them till the tail and the head match. Till the tail and the head match. The missing side of the triangle is the resultant, and the arrow mark always goes from the tail to the head. That's how you add it via the triangle law. The second one is parallelogram, but before that, let's see how do you subtract using triangle law. It's very simple. Imagine I again take one example like this is A vector. Let's say this is your B vector. I want to do A vector minus B. Like I told you before, subtraction is actually addition but with a negative of that other number. So minus B, what do you mean by minus B? If this is B, the opposite of the same magnitude is minus B. The opposite of the same magnitude is minus B. So let's try it out. Forget this now. It's like adding this with this. Okay, so what I can do, I'll take that A vector as it is, and then after this A vector is taken, I will take the minus B vector's tail on the head. The minus B is vector's tail on the head, right? That is how you have to use triangle law. So can you see there is a missing side over here? This is the missing side. This is the tail. This is the head. So the arrow mark goes like this. So hence this is A minus B. This is A minus B. Understood how the subtraction happens using triangle law? I will show you one more time, but the other way around. Imagine if it was B minus A. So it is as good as B plus negative A. So what is negative A? So negative A is basically this. This is negative A. So forget this now. Just look at this and this. Just look at these two. So take that B and put it over here, guys. Your job is done. So you have the negative A, of course. You have the negative A. Take that B and put it on the head of A. Put it on the head of A. So something like this. Something like this. So that is your B, guys. Now you see there is a missing side over here. Now you see that there is a missing side over here. So always start from the tail and go towards the head. So the arrow mark will be like this. So this is B minus A. This is B minus A. Now, one very interesting thing that you see is this length and this length will be same, just that the directions are opposite. Directions are opposite. So magnitude wise, A minus B or B minus A, magnitude wise is the same, but A minus B is definitely not equal to B minus A, as directions are opposite. Directions are opposite. So I will say they are not commutative. Not commutative. They are not commutative. Okay. So they are not commutative because their directions are not same. A minus B and B minus A would not give you the same thing. I hope this is clear. Yes. Yes. Is that clear, everyone, till this point? Okay. So I have just shown you how to use vector additions, how to use triangle law in vector addition, and also how to subtract vectors using triangle law. Main thing is in subtraction, you have to take the negative vector and then join the head with the tail, head with the tail, head with the tail, and draw the missing side. The arrow mark of the last missing side goes from the tail to head, always. Next comes is the parallelogram law. See, do not think parallelogram law is a very new law. It's actually triangle law only, just looked at it from a different perspective. Just because I stand like this and you see my left side, I am Shreyas Sir. If I stand like this, does not mean I will become some different sir. You're just seeing me from different angles. Same way, parallelogram law is actually triangle law, but slightly a different way of approaching. And it's up to you which law you want to use to add the two vectors. Okay, it's completely up to you which law you want to use to add the vectors. So in this case, the only difference is how you place the vectors. I have two vectors, I want to add them using triangle. I put the tail on the head of the next one and then see the missing side. In parallelogram, you do not put the tail on the head, just like how you measured the angles. Remember, what did you do to measure the angles? You attach the tails together, right? Same thing you're going to do. You're going to attach the tails together and you are going to construct a parallelogram and you will draw the diagonal starting from the common tail. You will draw the diagonal starting from the common tail. That's it. That is the resultant vector. Let me explain what do I mean. Let's take an example. Imagine this is vector A and let's say this is vector B and I want to add them using parallelogram law. Like I said, you will attach the tails together. So let's say, for example, this is vector A, this is vector B. So I will put it over here. Okay, just leave it as it is. The tails are joined together. Now the main thing comes, and that is basically constructing a parallelogram. Construct a parallelogram, draw a side parallel to A, draw a side parallel to B also, draw a side parallel to B also, something like this. So I hope you can see there is a parallelogram formed. Okay. Now from the common tail, just draw a diagonal. That's it. That is your A plus B. That is your A plus B. That's it. Now you might be wondering, sir, how is this like the triangle law? I don't know how many of you noticed this already in this particular parallelogram which I have shown. Let me just show it again. Okay. In this parallelogram which I have shown, if this is B bar, this is also B bar. Think about it. This and this is the same. If this is A bar, obviously even this is also A bar. And this one, the green one over here like this, that is your A vector plus B vector or B vector plus A vector. Look at this. If you look at the top part, you can see triangle B vector plus A vector. Oh, from the top part, it is B plus A. If you hide the top part, it is A plus B. The missing side of the triangle is the green one. So it is A vector plus B vector, which is one and the same thing. So you can see this is actually this, which is the triangle law. Okay. So guys, do not get confused and think, oh, should I use parallelogram or triangle? It's one and the same thing at the end of the day. It's up to you, your matter of choice, convenience. Which one do you prefer? Sometimes you will have to use multiple ways to understand the concept of parallelogram and triangle law. Okay. So in parallelogram, from the common side, from the common tail, draw the diagonal of the constructed parallelogram. That is your resultant vector. Can you also subtract using parallelogram law? The answer is yes, definitely. There is no harm in doing so. I mean, I can just show it to you right over here. So let's say, for example, oh my god, can't remove this. Okay, so maybe I can just put it over here. So if I have A and let's say if I have B and I want to do this operation A bar minus B bar, which is the same as A plus negative B. So first things first, take the negative of B. First things first, take the negative of B. Now forget this B, look at this and this, look at this and join their tails together. If you join the tails together, it will look something like this. This is minus B. This is A. You take it over here and put it like this. Now you construct your parallelogram. Construct your parallelogram like this. Perfect. From the common tail, draw a diagonal. That's it. That is your A minus B bar. That is your A minus B bar. Simple. Understood, guys? Everyone? Yes, Maziyad. We are going to start from the basics and go till the JEE advanced level. Yep. I hope this is clear. I hope this is clear. Why are we extending as parallelogram instead of joining the two heads of the triangle? See, NNK, you can make multiple methods. These are just ways of adding. You can create your own way and give it your name by joining the heads and finding out that geometrically it's the same thing. Direction is also same, magnitude is also same. You can give it your name. Okay. So in the parallelogram way, you are joining the tails. But if you join the heads, then you have to rewrite it saying that the head of the resultant will be coinciding at the common point. So it's one and the same thing. All right. Okay. Okay. Great. So let's proceed ahead. Let's proceed ahead. Yep. Okay. Okay. So let's proceed ahead and see whether you can solve this question. Prove that the resultant of two vectors is more inclined towards the bigger vector. That makes sense. I mean, just think about it. If I'm applying 2 Newton force versus somebody is applying 7 Newton force, 100% the resultant will be more towards the 7 Newton force because it is very huge. So this is the net force. The net force will be closer to the bigger force. Makes sense because it has more contribution. I am bigger. So the resultant will be closer to the larger force. But how do you prove it? King Cordium YT, if you want break, please, bacha, this is not the right place. I am not going to give any break. This is a non-stop class. Maybe at 7:30 or something, there might be a small break. Okay. So please understand, these are big classes. You are JEE students, 6 months are there. If you are thinking of about break after 1 hour, then it's going to be really tough to crack. Okay. We have 6 months. We have to have that aptitude, that mindset of a JEE aspirant. We cannot be writing the JEE exam thinking about the break. Okay, I hope you get it. All right. So the best way to do it using parallelogram law is you show one, let me show it like this. You show a parallelogram, one with a smaller side, one with a larger side. Now construct the parallelogram. Now construct that parallelogram. Now construct that parallelogram. Let's say like this, like this. The resultant is basically this one. This is the resultant. These were the two vectors. This is the smaller one. This is the larger one. Inside a parallelogram, remember, the one where the side is larger, obviously, this angle will be small. This angle will be small. The one where the side is small, you will see this particular angle will be the larger angle. You can guess this very easily. Imagine if this side were to become like this, then the parallelogram will become like this, and then the diagonal will come here. So the moment this side becomes large, this angle will become small, and this angle will become large. So definitely, it makes sense that if this was even smaller, then your parallelogram would have been only like this. Your resultant would be here. This would have become even larger. So that means the one which is smaller will have larger angle. The one which is larger in magnitude will have smaller angle with the resultant. So that's why the resultant is always closer towards the larger side. Is always closer towards the larger side. Is that clear, everyone? Very good. Awesomeness. Moving on to the next one. If A vector plus B vector's magnitude is A vector minus B vector's magnitude, show that the vectors are perpendicular. Using geometrical approach only, a lot of you might have done this problem, using analytical or formula method. But trust me, very few people would have shown this to you using geometrical way. Okay, so let's see how we can do this. First of all, A vector plus B vector's magnitude. So let's say, for example, I have taken some random thing. Let's say this is your A vector. Let me draw it slightly big. Let's say this is your A vector. Let's say this is your B vector. So A vector plus B vector will be like this. This will be A vector plus B vector. If I do A minus B means negative of B. So negative of B would be basically like this. Negative of B would be basically like this over here. This is your negative B vector. Now using triangle law, A vector with negative B vector will give me this vector, which is basically your A minus B bar. A minus B bar. A plus negative B is A minus B. A plus B is A plus B. It is clearly mentioned that A plus B is magnitude and A minus B is magnitude are equal, meaning this side is equal to this side. These two sides are equal. That is what is given to you. Now tell me one thing, my dear students. Do you know this property of an isosceles triangle? Do you know this property of an isosceles triangle, that when these two sides are equal, and you draw basically a median, a median is one which bisects the sides, then the median is also perpendicular to the base. The median is also basically perpendicular to the base. Do you know this property? This is the yellow one, is the median. The median is also perpendicular to the base for an isosceles triangle. Basically, these two sides are equal. This is a very, very important property. How many of you know this? Very good. So now, if this is now an isosceles triangle, and do you see over here, this side is equal to this side, because this and this is equal. This is the midpoint. So this is a median. So if this becomes a median, 100% this must be perpendicular. So naturally, A is perpendicular to B, just that I have not drawn it like that. Remember, whenever you have to prove something, never ever show the diagram as if you already know the answer. Never. That is not the right mathematical way. I know A is perpendicular to B, so you might be questioning, sir, why are you showing A at an angle at B? I do not know that yet. I have to prove that. So whenever you have to prove, you'll always assume the worst, and still in that worst condition, it will hold true. That's when the proof is valid. Is that clear? Yep. Thank you, Moni, for all the love. Very good. Excellent. Moving on to the next, which is the polygon law of vector addition. Now, what is this polygon law? See, we learned how to add and subtract two vectors. Poly means multiple. So when you have multiple things together, you add them. So how do you find the resultant? Using polygon law. It's actually an extended triangle law. How? In triangle law, you draw the missing side of a triangle. Imagine there were 4 or 5 vectors. You keep joining their head with the tail, head with the tail, head with the tail. You will find a nice polygon like a constellation and stuff. You will see a missing side of the polygon. The missing side of the polygon is the net or the resultant vector. As simple as that. So let's understand what do I mean by it. Imagine there are multiple vectors, and let's say this is vector A, then there is this vector B, then there is this vector C, then there is this vector D, and let's say then there is this vector E. That's it. So these are the vectors. I have to add them. Can you see it's a part of a big polygon with a missing side over here, with a missing side over here. That's it. This missing side is the resultant. So starting from the tail to the head, that's it. This is your A plus B plus C plus D plus E. That's it. As simple as that. Sometimes what might happen is when you are adding these polygons, it might even look like this. Okay, it might even look like this, and it might end over here. So there is a closed loop. There is no resultant or there is no missing side. So in this case, the net is a null vector. The net is basically going to be a null vector. That's something which you should be knowing. Okay. This is vector chapter. Vectors is a 11th standard thing, and this is physics. Okay. Yeah. So we are doing 11th standard physics right now. Friday, 12th standard physics, which is electrostatics. Okay. So in polygon law, you just add the vectors like a triangle law by placing the head with the tail, head with the tail, head with the tail. See the missing side. If there is no missing side, net is null. If there is a missing side, the remaining is the resultant vector. This is the resultant vector. As simple as that. So let's see if we can solve some questions based out of it. First question, I think level 1. Is it possible to add two vectors of unequal magnitudes and get 0? Is it possible to add three vectors of equal magnitudes and get 0? Come on, I want to see the answers in the chat box right now. Everyone. Is it possible to add two vectors of unequal magnitudes and get 0? I think you cannot, no matter what you do. If there is this vector A, even if you add this vector B like this, they are not equal magnitudes. So no matter what you do, you will always find an unbalance. So this is basically your A plus B. So the net is definitely not 0. So is it possible to add two vectors of unequal magnitude and get 0? The answer for this is a big fat no. How many of you said yes? Wrong. Answer is no for the first one. Yes, Adarsh. Perfect. Very good, Pratap. Excellent. Dharineshwaran. What about the second answer? Can you have three vectors of same magnitude and get 0? I think this is possible. Use polygon law. start with this, go to this, and come back over here. This and this and this same magnitude. Do you see you're coming back at the same point? There is no missing side. So here the net sum is a 0. So the second answer is a yes. The second answer is a yes. Perfect. Nothing wrong over here. Exactly. So we have used polygon law, and here we have just normally used the triangle law, nothing more. Okay. Now let's go to the next method, and that is basically called as the analytical method. Geometrical method is complete. Remember, I had just told you that there are multiple ways of adding the vectors. Let me just come back over here. Multiple ways. Graphical, 3 ways are done. Now let's go to analytical, and then let's go to IJK method. Let's also go to IJK method. Okay. So let's go over here. What is this analytical method? Now, in analytical method, what is given to you, I'll tell you first. What is given to you, usually, you will be given the magnitudes of the vectors, being added, vectors being added, vectors being added. Also, you will be given the angle, you will be basically given the angle between them, angle between them. And what you might have to find, is the resultant vector. Resultant vectors, magnitude, and maybe the angle which it makes. So what is given is the magnitude and the angle between them. What you have to find is the resultant's magnitude and the angle, usually. Sometimes the problem obviously can be twisted. They might give you this and ask you this. It's obviously solving the problem in the reverse way. But main thing is getting to know the formula. Okay. All right. So let's see what the formula looks like. So starting off with a simple derivation, it's very, very straightforward, guys. So imagine there is this vector A, and let's say, for example, this is another vector B. Okay, so I'll call this as vector A, and let's say this is vector B. This is O, this is A, this is B, and the resultant over here is this one, which is basically vector C. Okay, and we know that C vector is the resultant of A vector and B vector. I want to find everything about C. What is given to me is the angle between A and B. Now, if you observe carefully, B and A, head and tail is joined. So technically, I should put B here and then measure the angle so that A and B's tails are joined together. Another option is just slide this A over here. Just slide this particular A over here. That will also do. And then you measure the angle. So this is theta. So this is also fine. If I slide A over here, both their tails will be joined together, and the included angle is the angle between the vectors. So I know the angle. Now, in order to find C, you just do a simple geometrical construction, my dear students. It's not big. So you drop a perpendicular here, and you also see that there is a beautiful, nice little right angled triangle which is formed. I will label this as point D. So I want to find the side OB, given the side OA, AB, and the angle between them. So first of all, I can think of a theorem, which is Pythagorean theorem, because I can see a big right angle triangle being formed. So I can say for the triangle, basically triangle ODB, using Pythagoras theorem, I can say OB square will be OD square plus DB square Now, what is OB? The length OB is the length of the C vector. So I can also write it as C vector is equal to OD. Now, OD is OA plus AD. OD is nothing but OA plus AD whole square, plus you have DB square You can expand this, of course. So it will become OA square plus AD square plus 2 times of OA into AD plus DB square. That is what you are going to get. DB square is right from here. This is A plus B whole square is A square plus B square plus 2AB. Now I feel I know all these things, at least most of it. What is OA? OA is the length A over here. OA is basically the length A over here. So technically this is A square. Then AB. AB is not there right now. I need to get it somehow. AB is not there. So I need to get it somehow. How do I get that, my dear warriors? How do I get that, my dear warriors? Okay. Now for that, what we will do, check this out. In the small little triangle, that we have, can you see that sine of theta, which is opposite by hypotenuse. Opposite is basically BD upon hypotenuse is basically B. So therefore, BD is basically B sine theta. BD is basically B sine theta. Similarly, cos theta is adjacent, which is AD, divided by hypotenuse, which is basically B. So what is AD going to be? AD is going to be B cos theta. How about using it over here? AD square will be nothing but B square cos square theta. B square cos square theta plus 2 times of OA. OA is basically A only. What is AD? AD is nothing but B cos theta. And what is the DB? DB is basically B sine theta. So this will be B square sine square theta. Best part is this B square and sine square. B square cos square and B square sine square. Look at this. Look at these two terms. This is very important, guys. What will happen? To them? Sine square theta plus cos square theta is 1. Sine square theta plus cos square theta is 1. So technically this will become A square plus this will become just 1, right? So this will just be left with B square. Remember, because I have sine square theta plus cos square theta. If you want, I will write it together. And I have over here 2AB cos theta. This whole thing is 1. So hence it will just be A square plus B square plus 2AB cos theta. But that is C square. If I'm interested in C, I have to put it under the root. If I'm interested in C, till this point, this was C square. I'll put it under the root. So this gives me the magnitude of the resultant vector. What did it give me? The magnitude of the resultant vector. Till this point, everybody clear? Interesting part continues over here. Imagine if I continue with this same analysis and I'm interested in how much is the angle made by C, over here with A, the angle made by the resultant with A. What I will do, again in that big triangle which we have OBD, find the tan of alpha. Tan alpha will be opposite, which is BD, divided by adjacent, which is basically OD. Now BD, keep it as it is. Instead of OD, put it as OA plus AD. OA plus AD. What is side BD? Side BD, I think we wrote it over here only. It is basically B sine theta. What is OA? OA is basically A. What is AD? AD is basically B cos theta. Okay, fine. So this is basically tan of alpha. So I will get the tan of the alpha. So if you are looking at alpha, it is written down as tan inverse of this entire thing. Tan inverse of this entire thing, which is B sine theta upon A plus B cos theta. This is how you write it down. Okay, so this is the derivation, this is the proof of the formulas. Okay, one is finding the resultant, one is finding what is the resultant, that is what we had to find, resultant magnitude and the angle, given the magnitude and the angle between them. Same thing, given the magnitudes and the angle between them. I can find the angle, right? Everyone, till this point, is it absolutely clear? Okay, very good. Sir, will this series cover the syllabus? Yes. Yes, we are trying to do that only. Very good, Vignesh. You're from Tamil Nadu. A lot of students are there from Tamil Nadu. And let me tell you, my dear students, we need a lot of support from especially the students who are in Northeast, South, and even abroad. There are many channels which are there in Hindi medium or in English medium, but English medium, nobody is interested or making that efforts. And we have been here for the last 4 years for you guys. So it's your job and your responsibility to make sure that these channels are popular, because a lot of people will try to put us down, put you down, and mock you or even mock us. But remember, you have to stand straight. You have to make sure that this channel is for you and becomes popular. Okay, because only when you spread the word can we get that motivation and that excitement to produce more and more videos for free on the YouTube channel. Okay, so and the best part is, thanks to all of us, we have been creating a trend in a lot of states where earlier that awareness for JEE was not there. Slowly students have started to watch the videos even from small towns and villages where offline coaching can't reach, and students have been cracking the JEE like examinations in the past couple of years. So make sure that we spread this joy of learning. Okay, cool. So yes, moving on now that we know that this is the formula. Do you know that there is also a formula for vector subtraction? And you can guess, instead of C being A plus B, if it was A minus B, the only difference is this will be A square B square. Instead of plus 2AB cos theta, this will be minus 2AB cos theta. You can see that right over here. A square B square minus 2AB cos theta if it is subtraction. That's the only difference. That's the only difference. In fact, if I use these methods and go back to one of these problems where, remember, this was asked, prove that A plus B and A minus B, if they are equal, then show that they are perpendicular to each other. We did this geometrically. We can also do it analytically. We just did it geometrically. We can also do it analytically. What is A plus B? It is basically root of A square plus B square plus 2AB cos theta. What is A minus B? Modulus. It is A square B square minus 2AB cos theta. So the minus sign comes the moment it is minus here. That's all. You can forget the roots. The roots will cancel. The roots obviously will cancel. Once you cancel the roots, even this A square B square will cancel. And I am just left with 2AB cos theta is equal to minus 2AB cos theta. Okay, shift it here, it will become 4AB cos theta will be 0. But we know what? 4 can't be 0, A and B can't be 0. Therefore, the only number which can be 0 is cos theta. Now, whose cos is 0? Obviously, 90 degree. So, theta is 90 degree. Therefore, A vector is perpendicular to B vector, can be proved like this instead of geometrical way. But I had shown you two ways now. Okay, so I have shown you two ways and also shown you how to apply this particular formula. Is that right, everyone? Fine. Okay. Shall we do more questions? Very good. Let's do. Let's do. Here it comes on your screen. Two forces are there. Each are equal to F as shown in the figure. The resultant will be very interesting question. Let's see if you guys can figure this out. Let's see if you guys can figure this out. Honestly, you are a little bit late for the class, but hopefully if you have seen this part before, then I think you can continue, or else quickly go behind. Even in a live class, you can go behind and catch up maybe at some higher speed. Okay, try this out. Come on, my dear students. Come on, my dear students. Very straightforward question. First of all, the tail and the heads are not joined, so you need to be careful. The angle between the two vectors is not 60. That's the most common mistake. Actually, you have to shift this down. Only then it will make sense. Check this out. This is F vector. Shift this down like this. Then it will be correct. Then instead of this being the angle, this would be the correct angle, which will be 180 minus 60, which is 120. This is the correct angle. This is not the correct angle. Now you use the formula. So the resultant will have the magnitude a square plus b square plus 2 into a into b into cos of the angle, which is cos of 120. Okay. So f is common everywhere. So take it outside the root. 1 is remaining, 1 is remaining, 2 is remaining. Cos of 120 is negative half. 2 cancels, minus 1. Minus 1 plus 1 is 1. So it will become f root 1 plus 1 minus 1, which is f root 1, which is basically f. So hence the answer for this question is f. Otherwise, if you put cos 60, you will get it as half. So 1 plus 1 plus 1, 3. So answer would have been C option. So a lot of you wrote the answer as C, which is wrong. Getting it? The answer is not C because the angle is not 60. Look at the head and the tail. Whenever you have to add the vectors, subtract the vectors, etc. Okay, and you are measuring the angle between the vectors, especially their tails should be joined. Their heads should be joined to measure the angle. Okay, clear? Vignesh, rotation won't start now, but if you want rotation, you can do one small thing. You can just go to the channel, our channel only. Just search over here, rotation. Just search over here, rotation. You will find beautiful one shots by me. See, my playlists are already there. Zero to hero in rotation, one shot physics, rotation and rigid body mechanics. All the lectures are already mentioned over here. So you can use these lectures for your benefit. Okay. Right. Moving on to the next one now. The magnitude of the difference of the two vectors is equal to their magnitude. Now find the angle between the two vectors. This is level 2. I think directly with the formula you can get it. Directly with the formula, I'm pretty sure you will be able to get it. Think about it. How are you going to go through it? Come on. Very, very straightforward, my dear students. The magnitude of the difference of the two vectors. The difference of the two vectors means a bar minus b bar. Magnitude of the difference is equal to their magnitude, meaning this, meaning is equal to their means plural, so their magnitude. Then the angle between them is how much? That is the question. That is basically the question. Okay, so what do we do now? What do we do now? Think about it. Either you can go by the analytical way or the geometrical way. It's completely up to you. So a bar minus b bar's formula, what I'll do before applying that, let's say I assume this as x. The formula for this is a square plus b square minus 2ab cos theta minus 2ab cos theta. This is equal to x. This is equal to x. That is what it means because this is the expansion of this formula. A square plus b square minus 2ab cos theta. But a and b both are x. A and b both are x. Do not forget that. So it will be x square plus x square minus 2 into x into cos theta, which is equal to x. Square both sides. So this will become 2x square minus 2x square cos theta is equal to x square. X square will cancel. So 2 minus 2 cos theta is equal to 1. So bring that 2 cos theta there, bring that 1 over here. So 2 minus 1 is basically 2 cos theta, right, everyone? So basically 1 is equal to 2 cos theta. Therefore, cos theta is half. Hence, theta is 60 degree. That is the answer, 60 degree. How many of you wrote it? If you wrote it as 0, you're wrong. If you wrote it as 0, that is wrong. Heroic, you will be getting a break only after the vector addition and resolution part is over. Before that, there is no break. Okay, so there is a single break in this entire lecture. Okay, so please understand that. You can take a break at any point of time. It's up to you. This is a very, very important result or case which I would like to discuss with you, which is the maximum and the minimum resultant of two vector quantities. Just think about it. Just visualize this. Imagine if I have a vector A and I have multiple ways of aligning B. One like this, then 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 like this, and maybe like this. Okay, I'll do one thing. I'll put this as our A in a different color. Multiple ways of aligning the B vector. In each case, check how our resultant will change. Check how our resultant will change. When A and B are perfectly aligned, this is the resultant. Later on, what happens is the resultant is slightly different. Like probably it is this, then it slowly becomes this, then slowly it becomes this, then slowly it becomes this, and slowly it becomes this, and finally, when it is perfectly opposite, then it becomes this. So do you see the resultant as the vector B keeps on changing the angle? It is maximum here, it becomes less, and it becomes least over here. It becomes least over here when A and B are perfectly opposite to each other. How many of you are able to see this and visualize it? Are able to visualize it? A and B are perfectly aligned. It is the longest. So as B rotates, you can see the length keeps on reducing and collapses to the least value. So here it is basically minimum, and when aligned perfectly, it is basically maximum. That is exactly what I want to discuss on the next slide. So if the vectors are basically parallel to each other, that means theta is 0. That means the theta is basically 0. Then the resultant that they produce, that resultant C is maximum. The resultant is basically maximum in value. Is that right? And the magnitude is simply A plus B. The magnitude is simply A plus B. Both of them are in the same direction. They are helping each other out. They will produce maximum output. But if one of the vector is here, if one of the vector is here and the other one is exactly opposite to that, that means the angle is 180 degrees, that is they are anti-parallel to each other, then you will see the resultant will be minimum. This vector C is going to be minimum. This is going to be minimum. And this C will be the modulus of A minus B. Why A minus B modulus? Because I don't know whether A is big or B is big. It could be A minus B or it could be B minus A, whichever makes it positive. Whichever makes it positive, that's why I put mod symbol. As simple as that. As simple as that. Is that right, everyone? Okay. Clearo till this point? Very good. Guys, make sure that you are conversing in English and not in other languages. Yeah. You are on an English channel. We have done this for you. Okay. So this is something which you should be aware of. We can have some questions on this. Look at it. The maximum and the minimum magnitudes of the resultant of two vectors are 17 and 7. If these two vectors are at right angles, then the magnitude of the resultant is how much? Interesting. Look at it. The maximum magnitude is 17, meaning when you add them directly, the answer is 17. The minimum magnitude of the resultant is 7. That means A minus B modulus, assuming A is bigger, is basically 7. Question is, if they are at right angles, what is their magnitude? I think the first thing that we can do is actually find the values of A and B. That is the first thing which we can do. Just add both of them. You will get 2A, BB cancels, is 17 plus 7, right? Which is basically 24. So A will be basically 12. And therefore, B will be how much? It will be nothing but 17 minus 12, which is basically 5 units. So A is 12, B is 5. A is 12, B is 5. Now, both these vectors are basically at right angles. That means one over here, 12, and the other one, 5, is like this. So if I arrange it at right angles, what will the resultant look like? The resultant will be this missing side of the triangle. I have arranged the head with the tail of the next vector. I have arranged the vectors in such a way, head of one vector is with the tail, the missing side is by triangle law the resultant. So how much will that resultant be? Use Pythagoras, guys, directly. 12 plus 5 square, geometry, simple geometry. So this is going to be 13, right? Because 12, 5 and 13 are Pythagorean triplets. 12 square 144, 5 square 25, 144 plus 25, 169. Root of it is 13. That's it. So the resultant is 13 units. That is the answer. That is the answer. Very good. Many of you got it. Proud of all of you. Very good. Proud, proud, proud of all of you. Moving on to the next question. The resultant of two unit vectors is also a unit vector. Then find the magnitude of the difference. Interesting. It's just a play of words. If you look at it part by part, you will get it. The resultant of two unit vectors is also a unit vector. The magnitude of their difference is how much? First of all, let's understand this. Resultant of 2 is also a unit vector. This can only happen in one scenario. If you have a beautiful equilateral triangle, imagine one unit vector is here, the other unit vector is here, then the resultant can be like this. Resultant can be like this. This is having a magnitude of 1. Even this and this have a magnitude of 1. Both of them have all of them have magnitude 1 because all of them are unit vectors. So now quickly think and tell me, between these two vectors, this is vector A, this is vector B, this is your resultant. This is your resultant. What is the angle between A and B? What is the angle? What is the angle between A vector and B vector? Quickly think and tell me. First of all, this becomes an equilateral triangle. Lot of you will be tempted to say it is 60, but it is not 60. It is not 60, 100%. Think about it again. Why is it not 60? The head is attached with the tail. So be very careful. So guys, if A vector will be like this, shift that B vector over here, shift that B vector over here. And now this angle is the right angle, which is 120 degrees. This is the correct angle. 120 degrees. Got it? Now comes the next part of the question. The magnitude of the difference, meaning what they are asking is A vector minus B vector is the difference, the magnitude of this. Well, this we found out. Formula A square plus B square minus 2AB cos theta. Let's start. Root of A is how much? A is basically 1, magnitude is 1. 1 square. B is how much? Magnitude is 1 minus 2 into 1 into 1 into cos of how much? Cos of 120 degree. Cos of 120 degree. So 1 square is 1. 1 square is 1 minus 2 into 1 into 1, 2. Cos 120 is negative half. Cos 120 is negative half. So this will become 1 plus 1 minus minus becomes plus. So it will just become root of 3. Root of 3 is option number C. Root of 3 is nothing but option number C. That is the correct answer. No, it is not D. It is not A. Many of you got it wrong. Many of you got it wrong. Cool. Shall we go ahead? Shall we go ahead, my dear students? Very straightforward. Okay. So we went step by step. You have to dissect the problem. Look at it part by part. Resultant of two unit vectors. Oh, two vectors of magnitude 1. Okay. Is also unit vector. Okay. So that's how I drew the triangle. I found out the angle by knowing the theory. I cannot find the angle like this because head is matching with tail. I have to connect the tails together. Only then I can understand the next part, the difference is magnitude. So use the formula and we have got it. All right. Shall we go to the next one? Okay. And that is the resolution. After this resolution and unit vectors, we'll have a break. Okay. After this resolution and unit vectors, we are going to have a break. Okay. But for now, concentrate properly. How are you enjoying the class? Are you learning a lot? Are you understanding everything, my dear students? My dear lions, yes. Karthik, there is nothing like my wake up and sleep hours. If there is some news, I sleep late. If there is something, I wake up early. I sleep whenever I find time. That's all. Okay. And plus, I'm managing two channels, JEE and NEET, so you can understand. Plus the batches which are running, that is separate. Okay. Let's have a look at resolution of vectors. Now this is very, very important. What is the meaning of resolution? The word resolution means to break into parts. Parts also mean components. Imagine there is a pandu. Imagine there is a pandu, very, very happy pandu. If I say, let's resolve pandu, let's resolve pandu, meaning I'm going to break pandu into multiple parts. So maybe one part will be this, one part will be this, his eyes, this eye, one hand, another leg, another leg. All these are now separate entities. This is one part, this is one part, this is one part, this is one part, his body is one part, this is one part, this is one part. All these are basically separate parts. You've broken it down into separate parts. So when I say resolving a vector, you are trying to cut it down into smaller vectors, splitting, yes, correct. So you will be like, what do you then exactly mean by resolution of a vector? Because a lot of people then start thinking, sir, if I have a vector like this, do you mean that I have split it like this? I have split it like this? Well, yeah, that is one way of splitting a vector. This is one way of splitting a vector. Definitely, I can cut it into, it's like taking a knife and cutting a cucumber. Tuck, 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 you cut a cucumber, you get small slices. Fair enough. That's also, resolving a vector. But trust me, there are multiple more ways of resolving a vector because law of polygon. Imagine I resolve it into a part like this, like this, like this, and like this. These are like again four parts of the same vector because if I combine these parts, I get back the same vector. See, always the parts should be such that when I combine them back, I should get back the original thing. Like if I combine back the eyes, hands, legs, nose, everything, I get back the original Pandu. Same way over here, if I combine them using polygon law, I get back the original vector. So they are also the components. So there can be even more components for any vector. Let's say there is a vector here. I can split it up like this. This plus this plus this plus this plus this plus this plus this. All these are basically parts of the vector. These are basically parts of the vector. I can also say this is the components of the vector. So tell me, my dear students, my lions, how many different ways are there? How many different ways of there for resolving a vector? Put it up in the chat box right now. How many ways are there? Come on. So the number of ways to resolve a vector. How many are there? Yes, very simple answer. Excellent. What is it? Infinity. So many ways I can split in so many different ways, like this, like that, like this, like that. So there is no, fixed amount or finite ways. It is definitely going to be infinity. Exactly. Infinite ways. Infinite ways. Okay, so there is no fixed number, infinite number of ways are there. So like, sir, then what is the point of learning this? Because if there are infinite ways of cutting it, what's the use? I mean, can you bring it down to a smaller number? Well, I will. How? I'll tell you. If I have a vector, and I split it into such a way that all the components are perpendicular to each other, then usually the maximum number is 3 number of parts. Usually the maximum number is 3. So, for example, there is a vector like this. I split it into a part this way and this way. That's it. It has two components which are perpendicular to each other. Not just that, I can make it even more crazier. But for that, I need to draw a cube. Imagine this vector. Are you able to visualize the cube? Are you able to visualize a cube? I know it's not that great, but definitely able to visualize. How about writing it this vector? Check this out. How about writing it as this vector plus this vector plus this vector? And the best part is this is perpendicular to this is perpendicular to this. All the three are mutually perpendicular to each other. All the three are mutually perpendicular to each other. So these type of components which are not of that infinite kinds but of a very peculiar type which are perpendicular to each other, these are basically perpendicular components. They are also referred to as rectangular components. Rectangular components. Why did we do this? There are advantages. Number one, I can apply some properties and visualize, and I can visualize easily. Because if I had to visualize 3D without a cube, it will be difficult. Or 2D without a triangle, it would be difficult because there are so many infinite ways. I can apply Pythagoras theorem. I can apply Pythagoras theorem. Not just that, I can also apply trigonometry rules. And all the any other properties that are there. I can apply all these things for triangles, cubes, squares, rectangles, etc. That is the reason why we use it. Is that clear? Yes, Rishabh, football, DPP, Magad, Supriya, understood, clear. Yep, awesome. So these are called as rectangular components where the components themselves are perpendicular to each other and it makes the job easy. Visualization, Pythagoras theorem, trigonometry, etc. can be applied in a much easier format. So if it is a two-dimensional problem, generally you will have two components. If it's a three-dimensional problem, then you will have three components. Then you will have three parts or three components. The component which is along the x-axis is called the x component. The component which is along the y-axis is called as the y component. The component which is along the z-axis is called as the z component. So you can have a vector. You can have a vector, let's say like this. Oops. You can have a vector like this, and it could be made of three mutually perpendicular components or two components. So it could be, let's say, like this, plus like this, plus like this, maybe. Just giving you some random example over here, like this. Okay, maybe this is the x component, maybe this is the y component, maybe this is the z component. So our original vector can be split into three components: x component, y component, and the z component. X component, y component, and the z component. This is in 3 dimension. If it was in 2 dimension, then it would look very, very easy. This would be our vector. This would be our vector, and you will just see two components. One component here, another component here. Maybe the y component and the x component. As simple as that. So, my dear students, in this case, it would just be v vector is simply x component and the y components. If I add them, I'll get back the original vector. Now, I have a simple question for you. Can you tell me just v, or basically v modulus value, just the length of this or the magnitude of this particular vector in terms of these two? Look at this. If you apply Pythagoras, this is what I exactly mentioned over here. We can apply Pythagoras, other properties, trigonometry exactly very easily. So this side is the hypotenuse. Therefore, shouldn't it be nothing but the root of Vx square plus Vy square? The two sides square under the root should give me the hypotenuse, yes or no? I can use the Pythagoras theorem. Exactly. Yes, vocals, it will end much before 10 o'clock. Same way, over here, we can use the properties of a cube. This actually becomes the diagonal of a cube. This becomes the diagonal of a cube. And I hope you know this particular property. When you have a cube like this, when you have a cube like this, and when you have a diagonal, when you have a diagonal, when you have a diagonal like this, and if each of these side has length, breadth, and height or whatever, then the diagonal is basically root of basically length square plus breadth square plus height square. Length square plus breadth square plus height square. And the length, breadth, and height are basically x, y, and the z components. Are basically x, y, and the z components. So hence, the value of v, or the modulus of the vector is simply put root of x square plus y square plus z square. Length, breadth, and height. As simple as that. As simple as that. Okay. Shriram, when you solve the solved examples, only then you will understand it. Without that, it will be difficult. When you start with a book with basic, then moderate, then PYQ, okay, then advanced PYQ, and all of this with the theory and maybe solved examples with the class notes and DPP, then it becomes a systematic flow. You cannot immediately after the class, let me open JEE Advanced PYQ or JEE Mains PYQ. That is a wrong approach. Always go in a very smooth transition. So sometimes I also recommend my students go with Tatva modules, okay, because they are systematically arranged. You can find the link which is there in the description box also. I think we have a link for the store for buying these books. I will just show it to you in case you are not aware. All right, let's see if we can go down. Maybe it should be there in the description box of this video too. Let's just see. And by the way, smash the like button in case you have not done that yet. Yeah, you can see best book for JEE preparation. Just click on this particular link. Just click on this particular link, JEE PCM Tatva material. It's black and white and color edition. Both are there. One is for 4,200, one is for 4,999. So you can check this book. It's there. You also have other books for advanced and everything. This Tatva book is both 11th and 12th standard modules for physics, chemistry, mathematics, all of them together for all the chapters, complete set of 22 books. You can use this from basic to advanced level. Okay, this is one such book which you can use. Okay, till this point is everybody clear? Till this point is everybody clear? My vocals, I will just check it and I will upload the DPPs in the Jungle book also. Okay, cool. Bacha, we'll talk about NEET on the NEET channel, not over here. Okay, let's continue with the flow of the syllabus in this ROAR series. Okay, now that you have understood, okay, I can split a vector into multiple small parts which are perpendicular along the x, y, and the z axis, x, y, z component, and how their magnitude is related to the individual component's magnitude. How do you know what these components are? How do you know what these components are? There is a very simple way of knowing it, guys. I'll teach you in a very easy manner. Observe this. Imagine there is a vector like this and you split it into two components. Split it into two components, one here and one here. If this is the x-axis, I will call this as the x component. If this is the y-axis, I'll call it as the y component. Same way, let's say, there is a vector here and you split it into two components, one over here and the one over here. This is the x component, this is the y component. If by chance you know that this angle is theta, then observe this carefully. Cos theta, which is adjacent by hypotenuse, will be Vx by V, and sine theta, which is opposite by hypotenuse, will be Vy by V. So therefore, observe this, Vx will be V cos theta and Vy will be V sin theta. Now remember this phrase, cos, that word C stands for closer, Observe this, angle theta, which of the two components is closer to theta? X component is closer to theta, y component is far away from theta. So the closer component is always the hypotenuse times the cos. The farther component committed a sin, like you have good deeds and bad deeds and you commit a sin when you do a bad deed. So when you go far away, then you commit a sin. So basically it will be, okay, it is basically the sine component. What is it called? The sine component. Same way, for example, I mark this angle as theta. Now you only think and tell me, out of the x and the y components, who is closer to theta? Obviously y component. So Vy over here will be the hypotenuse cos theta, and x component is far away from theta. So the x component will be V sine theta. As simple as that. Cool? Simple? Easy weasy? Okay? Clearo? Awesome. Awesome. So now let us take some examples to understand this. Let us take some examples to understand this. So in fact, I will show it to you right over here before showing the next slide. Imagine there is a vector of having a magnitude of 20, and let's say, it is making an angle of 60 degrees with the x-axis. 60 degrees with the x-axis. Can I split it into two components? The answer is yes. One component will be here, the other component will be here, or you can also alternatively show it like this. This is 20, this is 60. It's one and the same thing. One component here and the other component here. It's one and the same thing. You can shift this component here. You can shift this here. It's one and the same thing. This is Vx, this is Vy. This is Vx, this is Vy. 60 is closer to x, so 60 will be cos for Vx. Okay, so it will be hypotenuse cos 60. Why cos? Because it is closer. C for close. So cos 60 is basically half. So hence it will be 10. Same thing. This is also 10 only. Okay, because it is 20 cos 60. What is y? It is far away. It is far away from that angle. So hence it will be 20 sine 60, which is 20 root 3 by 2, which is 10 root 3. That's how you figure out the components. That's how you figure out the components. Is it clear, my dear students? Everybody with me? Let's take one more example. Let's take one more example. Imagine there is a vector like this of magnitude 10, and it makes an angle like this, 30 degrees. It makes an angle 30 degrees. We want to find out the components of it. First things first, one component will be x component, the other will be the y component. If you want to place that y over here also, there is no harm. It is one and the same thing. Both of them together will give you the same resultant. Both of them together will give you the same resultant. Okay. My vocals, maybe there was an error. I will just check it and I'll upload the DPP. Don't worry about it. Okay. Concentrate on the class. I will do it. Don't worry. Okay. So now this y component is closer to 30. So that's why it will be the cos component. So 10 cos 30. So it will be 10 root 3 by 2. So it will be 5 root 3. This x component is far away. So it will be 10 sine 30, which is 10 into half, which is 5 units. Is that absolutely clear, my dear warriors? Okay, how we did this? Okay, let's take one last example. Imagine there is a vector whose magnitude is 50, and it is making an angle of 45 degrees like this. So what I will do, I'll split it into components. One component here, another component over here. This component is along the y-axis, so this is Vy, and it is closer to 45, so it will be 50 cos 45. What is cos 45? It is 1 by root 2. So it is basically 50 by root 2. This x1 is far away, so it will be sine component, so 50 sine 45. Sine 45 is also 1 by root 2, so it is also 50 by root 2. Is that okay, my dear warriors? Yep. Is it clear? Understood till this point? Okay. What if by chance our vector is already like this, of magnitude let's say 50, or let's say it is having a magnitude of 30, then understand when you split it, there is only x component. There is only x component of 30. The y component is not there at all. The y component is 0, completely not there. How will you split it? It's already along the horizontal. Same way, imagine there was a vector of magnitude 15. How will you split it? Already it is along the y-axis, so y component is 15, but the x component is 0 magnitude wise. Is that right? There is no x in it, there is only y. Correct. So that's how you resolve or split a vector into components. Let's see if you guys can solve this question. A vector has a component along x equal to 25 and along the y equal to 60. Find the magnitude and the direction of the vector. But Vx is in the negative direction in the previous. Oh, Siva, we are only talking about the magnitudes over here. Sign wise, if you go, it will be negative. We are not talking about the sign. We are just looking at the magnitude, the length of these. Even likewise, this should be -5. But if you put a bar over here, then it will be minus. But we are just talking about the magnitudes. We're just talking about the magnitudes. Is it okay, Siva? Yes, Divakar. So understand Vx just means Vx bar's modulus. So this will be positive. We are not talking about the signs. That signs will come later on. That signs will come later on when we put a bar over it with minus I cap, minus j cap, minus k cap, all those things. Okay, so let's draw this. What are the components? A vector has a component along the x-axis equal to 25 units. So this is basically 25 units. This is basically 25 units. The y-axis component is basically 60 units. Come on, my dear warriors. Draw it and see it for yourself. Draw it and see it for yourself. Come on, come on, come on, come on, come on. Everyone, everyone, come on. Draw it and see it for yourself. How does it look like? Yep. Very good. I hope you guys have got it. Yes, what is this? 60, right? So this is 60 units. The resultant will be like this. This is what the resultant will be. These are the two components of it. These are the two components of it. So what is the resultant? Use Pythagoras. It will be root of 25 square plus 60 square. Is it Pythagorean triplet? I think it says this is 625 plus 3600, which is basically 4225. Oh, this is basically 65. So the resultant is basically 65. Perfect. What about the angle? What about the angle made by the resultant with the smaller one, let's say? So I can use tan theta if you want. So tan theta will be opposite by adjacent. So divided by 5, it will become 12. Divided by 5, it will become 5. So theta will be tan inverse of 12 by 5. That is the answer. So the angle made by the smaller vector is tan inverse 12 by 5, and the resultant is having a magnitude of 65 units. That's it. As simple as that. Cool. So this is how we solve the question. Next question, level 2, JEE Mains previous question. XY plane, the vector makes 30 degrees with the y-axis. The y component is this much. The magnitude of the x component will be how much? Okay, so we have a vector which makes, this is a vector, and that vector makes how much? 30 degrees with the y-axis. The magnitude of the y component is 2 root 3. So this, my dear students, is 2 root 3, and this angle is basically 30 degree. The question is, how much is the x component, if I'm not wrong? Yes, what is the x component? Well, this x component, if you want, you can also put it over here also. There is no harm. This is also x. Just slide it here. This is a nice 90-degree triangle. So you can see tan of 30 degree is basically opposite by adjacent, which is 2 root 3. Tan 30 is 1 by root 3. Tan 30 is how much? 1 by root 3. Root 3 cancels. So therefore, Vx, take that 2 on the upper side, it will just become 2, which is option number D, which is nothing but option number D. Everyone with me on this? Yep, option number D. Clear? Very good. How many of you wrote it? Awesome, Divakar. Awesome. Awesome, Siva. Got it. Perfecto. Uh, great. 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 So cool. So cool. Amazing. Amazing. Okay. Next question. The angle between the vector q and the resultant of 2q plus 2p and 2q minus 2p is how much? This is again level 2 question. J means PYQ. Let's see if we can solve this. The resultant of this and this. Okay. Just add them. 2q plus 2p with 2q minus 2p. 2p cancels. I think it will become 4 times of q. So now the question is, find the angle. Find the angle between this and this. If you have q vector, what will be 4q vector? 4q vector will be like this, 4 times of that. So what is the angle between them? Oh, come on, guys. The angle is going to be 0. They are in the same direction. They are in the same direction. So what is the angle? It is going to be 0 degree. So where is 0 degree? It's option number B. You see that other options look so confusing and so scary. Any student seeing it in the actual exam might think, oh, it's a very difficult question. So many variables are there. But actually, it was such an easy question which was asked. Such an easy question which was asked, right? So sometimes, the questions look scary, but the solution is very simple, or the answer is very, very simple. Now, this is level 3 question. Let's see if you guys can figure this out. If V1 plus V2 is perpendicular to V1 minus V2, then V1 is perpendicular to V2, V1 is equal to V2, V1, I think some option is missing. C option, I think something is missing. The angle between V1 and V2 can have any value. I think maybe V1 was not equal to V2 or V1 is 0. Something might have been there. I am doubtful about what was there here. But okay, let's look at A, B and D option. This is more than one option can be correct. More than one option can be correct. Yes. So let's see. How do we solve this? If V1 plus V2 is perpendicular to V1 minus V2, then what can you say about V1 and V2? Okay. Now, since both of them are perpendicular to each other, the resultants, this can only happen, check this out, if you have V1, if you have V1 plus V2 and you have V1 minus V2 and they themselves are perpendicular to each other. Imagine if this is V1, this is V1, if this is V1, this is V2, if this is V2, this will be V1 plus V2, this will be negative V2, this will be negative V2, right? So technically speaking, I should have put this over here. Okay, so this is V1 minus V2. Now, these both are perpendicular to each other. Okay, interesting. And this looks like somewhat our older problem. This is V2, this is V2. So this and this are also equal. Okay, this is the median. Okay, perfect. So should V1 be also equal to V2? V1, should it be perpendicular to V2? And the angle between V1 and V2 can have any value. A lot of you will be tempted to think V1 is perpendicular to V2. Think and tell me. A lot of you are tempted to think about it. Yes or no? How many of you are tempted? Come on, put it up. How many of you are tempted to think that way? I knew it. I knew it. Many of you will be tempted to think that way. But why? I mean, why should V1 be perpendicular to even V2? Is there any reason behind it? Is there any sense behind it? Why should it be even perpendicular? Just because you feel like it? Just because you think that it is, right? So, this is not necessarily true, guys. I mean, can't we have, just imagine, can't we have a right angle triangle, can't we have a nice right angle triangle? Can't we have a nice right angle triangle with a hypotenuse? With a hypotenuse, you take a midpoint over here, you take a midpoint over here, and you draw a median. You draw a median. You draw a median. Okay, perfectly. Now, in that right angle triangle, this side and this side may not be equal. Maybe this is small, maybe this is big. They are two unequal sides. You have drawn a median. Yes, in that median, because of that, this and this part will be equal. But what guarantee that the blue part will be equal to the yellow part? The blue part could be something else only. The blue part could be something else only. So the blue part, if it is V1, the this yellow part, you can see that they might not necessarily be perpendicular to each other. They might not necessarily be perpendicular to each other. You can see that it's just a median. It might not exactly be 90 degree. So yes, V1 is perpendicular to V2 is not necessarily correct. I think the angle between V1 and V2 can have any angle. It can have any angle. It's just a random median. It is just a random median. They never said V1 plus V2 is equal to V1 minus V2. They never said these two sides are equal. This is an isosceles triangle. They never ever said that. They never ever said that. Got it, everyone? Yep. It's not an isosceles triangle. I will mention this. This is not an isosceles triangle. Very, very crucial, guys. A lot of people think that this is an isosceles triangle. Is this clear till this point? Is this clear till this point? Very good. Next important thing. Next important thing. What about their lengths? What do you think about their lengths? Do you think their lengths will be equal or not equal? Do you think their lengths should be equal or not equal? That is the next important thing. What do you think about it? What do you think? Will V1 magnitude be equal to the V2 magnitude? Yes or no? Will it be equal or not? Will it be equal or not? Because V1 plus V2 and V1 minus V2, right? Okay. How about I write V1 over here and let's say V2 over here. I don't know whether they are equal or not. Using the laws of parallelogram, So let me construct a parallelogram like this, Okay. So this one over here, is basically your A plus B. This is basically your A plus B. From the common tail, you join the diagonal, that is A plus B. Guess what? If I take this V2 and make it opposite, if I make this V2 like this, it will become minus V2. So this is minus V2 and V1. So in the triangle form, so it is going to be V1 minus V2. Basically, this is going to be V1 minus V2. So I get another thing which is over here, and that is basically V1 minus V2. Minus V2 is here, V1 is here. Perfect. This is V1 minus V2. This was like A plus B. So this is like your V1 plus V2. Now it is clearly mentioned that these both are perpendicular. These both are perpendicular. That means this is basically 90 degree. So in a parallelogram, if the diagonals are perpendicular, what does it mean? What kind of a parallelogram it is? What kind of a parallelogram it is, my dear students, my dear lions? If the diagonals are perpendicular, what does it mean? It means only one thing. It's basically a rhombus. It's basically a rhombus. Perfect. And if it is a rhombus, that's it. Our job is done. The sides are equal. The sides are just going to be equal. So this is equal to this. That's it. But they may not be perpendicular because I don't know whether it's a square or not. So sides are equal, meaning V1 should be equal to V2. V1 should be equal to V2. That is why it is a proper, where is it? Level 3 question. It's a proper level 3 question. Got it, my dear students, my dear lions? Concentrate on the class. Yep. Yep. So very simple geometrical property I have used, which is, this one was major diagonal, that was V1 plus V2. The other diagonal is obviously the vector subtraction. I just showed you why. This is negative V2 plus V1, negative V2 plus V1. So they both are perpendicular, so it becomes a rhombus where the sides are equal. So let's find out whether the answers are correct. Yes, V1 is equal to V2. The angle between them can have any value. Perfect. Now let's go to the last few things, which is vector notation in unit vectors and the vector product. These are the two major things which are remaining now. Now remember, I told you sometime back there are three special vectors: I cap, j cap, and k cap. Correct? I cap is along x-axis, j cap is along y-axis, and k cap is along z-axis. I, j, k is along x, y, and z respectively. They are special vectors, they are unit vectors. That was one thing which I told you. So let's write it down over here. Let's write it down over here. X-axis, y-axis, and z-axis. We have special vectors. I cap, j cap, and then you have k cap. That was the one thing. Second thing which I told you was any vector can be resolved into three components or two components in 2D or 3D. One is the x component, one is the y component, other one is the z component, such that the magnitude is vx square plus vy square plus vz square, such that the magnitude of that vector is the root of vx square plus vy square plus vz square. This is what I have been telling you. Now, I have an idea over here. I have an idea over here. Observe this carefully. How about I combine both these things together in one single thing and write a vector in a very elegant manner? See, I'll tell you what the problem is. I'll tell you what the problem is. If I had to write a plane, a plane flies, a plane flies at 700 kilometers per hour, making 60 degrees with ground, making 60 degrees with the ground, and 30 degrees with east towards the north, towards the north. It sounds only so confusing. It sounds only so confusing. Imagine writing this every time whenever you want to play with vectors: forces, velocity, acceleration, momentum, field, weight. So many vector quantities are there, and every time you have to write these big sentences. It's obviously going to consume a lot of your time. So hence there must be a better way of writing this, and it must be easier also to operate. So that is basically your unit vector notation. So how does this work? Observe this. Imagine this is, let's say, I cap. If I go along the x-axis, if I go along our x-axis, let's say 3 times, then I will put I cap also 3 times. I'll put I cap also 3 times, correct? So totally together, this will become 3 I cap. If I go 4 times, I'll put 4 I cap. If I go 7 times, 7 I cap. What is this 3, 4, 5, etc.? That is the magnitude. So I might be going certain number of times. So let's say I'm going Vx number of times. Every time I cap, I cap, I cap. So Vx is that number. Vx is that number of times I'm going along the x-axis. It could be 3, 4, 5, 6, 100, 10.5 times, 3 times, 2.9 times, 1.6 times. It could be some number. Okay, so that is your Vx into I cap. Same thing I can do along the y-axis also. Let's say j cap. 2 times will be like this, 3 times, 4 times, 5 times, 7 times, 8 times. So maybe Vy times j cap represents the total vector along the y-axis. The total vector along the y-axis Vy is any number, 2, 3, 0.5, 0.9, 1.8, 1.678, anything. So now, if I combine both of them, Vx I cap this way, Vy j cap this way, you can use your parallelogram law or any law that you want. Okay, this was the y-axis. If I combine them together, won't I get this particular vector? Won't I get this particular vector? This is in the x direction, this is in the y direction. This Vx I cap is basically your x component. This Vy j cap, imagine I call it as your y vector component. So this is a vector, this is magnitude, this is unit vector. So combining both of them together, won't I get my original vector? These are the two components of it. So this is just as simple as Vx bar, which is Vx I cap, plus Vy bar, which is nothing but Vy j cap. Isn't it the same thing? Isn't it the same thing? I've written down the vector into some number I cap plus some number j cap. This is a better way of writing this vector. This is a much easier way to understand that vector. And I will show that to you by showing you more examples now. Yeah. And this I can do it even in 3 dimension, by the way. This I can also do it in 3 dimension. Imagine I have a vector like this. I have a vector like this, and you can obviously take 3 different components. One is like this. Yep, this is Vx bar, this is Vy bar, this is Vz bar, right? Something like this. And this could be, let's say, I cap. So Vx is basically Vx I cap. This could be j cap. So this could be Vy j cap. This could be k cap. So Vz will be Vz times of k cap. So our V vector, therefore our V vector will be nothing but, either you can write it as Vx bar plus Vy bar plus Vz bar, or in terms of some number, it is Vx times I cap plus Vy times j cap plus Vz times k cap. And if you are interested obviously in the magnitude, just like before, it is nothing but root of Vx square plus Vy square plus Vz square. That is what it is. That is what it is. So let's take an example to understand this. Say for example, my dear students, my dear lions, these are your x and y axis. These are your x and y axis. So if I put 3 times I cap, I cap, I cap, I cap. So this will become basically 3 times I cap. And I put 4 times j cap, 1, 2, 3, and 4. This is 4 times of j cap. If I combine these two vectors together, I'll get this resultant. I will get this resultant vector. This is 3 I cap in x, 4 times j cap, 4 times, I cap 3 times. So this is the resultant of these two. Do you guys agree with this? This is basically the resultant of these two. These are the two components of it. So my dear lions, won't this V bar be nothing but 3 I cap plus 4 j cap? 3 I cap plus 4 j cap. I have now represented that vector in terms of the unit vector, which is now very easy to understand, and solve. Now, if somebody asks me what is the modulus, the magnitude of this vector, meaning take the component, square it, add it under the root. So all you have to do is take the components 3 and 4, square it, add it under the root. This will be basically 5. So the length of this is basically 5 units. The length of this is basically 5 units. As simple as that. Understood, my dear lions? Now, I will give you now many more examples. Say, I write a vector like this, minus 2I cap plus 4j cap. Now, the moment this minus 2I cap comes, you should immediately think, oh, I'm not going along the positive x-axis, rather I'm going along the negative x-axis. So, what you should think is I should go minus 2 units, or rather 2 times I cap. So, this is minus 2 I cap. This is minus 2 I cap. 4 j cap. So, j cap, j cap, j cap, j cap, 4 times. So, this is basically your 4 j cap. So, the resultant of this will be somewhere over here. This is the resultant of this. That's it. Minus 2 I cap plus, oh sorry, why did I put plus 4 j cap here? I'm so sorry, guys. Plus 4 j cap, sorry, my bad. Plus 4 j cap. 1, 2, 3, and 4. So that is your plus 4 j cap. So the resultant will be somewhere over here. That's it. That is your resultant. That is your resultant. If they ask you what is the magnitude of this, well, that is going to be minus 2 square plus 4 square plus 4 square, which is 4 plus 16, which is root 20, which is 4 into 5, which is 2 root 5. The answer is 2 root 5. That is the length of this vector or the magnitude of this vector. Got it? Similarly, let's say another question I'm giving you. Let's say there is a vector which is 2I cap, or let's say 0.2 I cap plus y j cap minus point, let's say 4 k cap. And I tell you, this vector is an unit vector, Question is, find the value of y. Question is, find the value of y. That is the question. Can we solve this? Well, this vector is a unit vector. That means the magnitude of this vector is 1. The magnitude of any vector is taking the x component, taking the y component, taking the z component. Even if it is negative, it is squared, and that is 1. So 0.2 square is 0.04 plus y square. 0.4 square is basically 0.16, that is equal to 1. So my dear lions, what is the value of y square coming out to be? 1 minus 0.16 plus 0.04 is nothing but 0.2. So it is 1 minus 0.2. So therefore, y square will be 0.8. So y will be root of 0.8. Y will be root of 0.8. Understood? So for this value of y, this vector will become an unit vector. This vector will become an unit vector. Let me give you another question coming up on your screen, guys. Level 2 question. Let's see if you guys can solve this. Which of the following is an unit vector? Which of the following is an unit vector? Options are first one, okay. Multiple options could be correct. I cap minus j cap, I cap by root 2 plus j cap by root 2, I cap plus j cap minus k cap, I cap by root 3 minus j cap by root 3 plus k cap by root 3. More than one can be correct. Think about it carefully and let me know which of the following is or are unit vector. Is or are unit vector. Come on, my dear lions, figure this out. Kaushik, watch the lecture from the start. Cap means unit vector. It's just a way of telling that, listen, that is having a magnitude of 1. Okay, if it is bar, it can have any magnitude. If it is cap, it has to be having a magnitude of 1. Okay, let's see. Try to find out all the magnitudes in each of the cases. In the first case, the magnitude will be 1 square plus negative 1 square, which is root 2. This is definitely not 1. Here, it will be root of 1 by, here it will be 1 by root 2 square plus 1 by root 2 square, which is 1 by 2 plus 1 by 2, which is root of 1, which is 1. Here it is root of 1 square plus 1 square plus minus 1 square, which is root of 3, which is not 1. This one is root of 1 by root 3 square plus 1 by root 3 square plus 1 by root 3 square, which is just 1. Perfect. So hence the correct answers for this question are D option and B option. D and B both are unit vectors. A and C are not unit vectors. Exactly. Very nice. Proud of all of you. Proud of all of you. Very good, Joseph, Dharaneshwar, Vishal, Honey Happy, Abhay. So good. Raja, Mesu, Siva Clear. Very good. Awesome. Awesome. Now that you have understood till here what is a unit vector, let me tell you, you can also find a unit vector along some another vector, which is a very common thing. A unit vector along a vector. A unit vector along a vector. What does it mean? Imagine you have a vector like this. You have a vector like this. Along that line, it could not be x-axis, it could not be y-axis, it could be some random direction. If I go 1 unit, if I go 1 unit along that, if I go 1 unit along that, I will call it v hat. I'll tell you why also. Just imagine, my dear students, if this is x-axis, if I go exactly 1 unit, I call it I hat or x cap. So same way, if I'm going along v direction, along that I will call it v cap. As simple as that. Now think about it. This v cap, if I put it one after the other, how many times do you think I can put this? How many times do you think I can put this v cap? V cap, V cap, V cap. How many times? I think it will be V number of times. V number of times, which is the magnitude number of times. That is what will give me V bar. That is what will give me V bar. I'll just give you an example. Imagine when I say 5 times I cap, 5 times, I cap 5 times. So what is this 5? That is the magnitude of the vector. That is the magnitude of the vector. Imagine, similarly, if I have a vector of magnitude 7, I break it into 7 parts. Each part has a magnitude of 1. I will be doing it 7 times to get the total vector. I'll be doing it 7 times to get the total vector if 7 is basically the magnitude of the vector. So same way I can say, if V is the magnitude of this vector, I will put V hat magnitude times to get back the original vector, and therefore my dear lions, V hat is always the vector itself, the whole thing divided by the magnitude. This relationships looks very weird at times in the initial phase. Like, sir, V bar by V, what is this even? Like, how can I get V hat? Don't worry, I'll show you an example for this. I'll show you an example for this, you will get it. Find V hat for V bar is equal to 4 I cap plus 3 j cap. Okay, just try to find V bar, which is 4 I cap plus 3 j cap. Find the V hat for that. Let's go completely by the formula, nothing more, nothing less. V hat is V bar by V. V hat is V bar by V. What is V bar? V bar is 4 I cap plus 3 j cap. What is V? This is the magnitude. Remember, this is the magnitude. Magnitude of any vector. Take the component, square it, put it under the root. Oh, so this will be 4 I cap plus 3 j cap. The whole thing divided by 4 square 16, 3 square 9. Under the root of 25 will make it 5. So, which means V hat will be 4 by 5 I cap plus 3 by 5 j cap. Now, what does this mean? It means, observe this carefully. Observe this carefully. This is your x-axis, this is your y-axis. If you show the original vector 4i plus 3j, 4i and 3j, I think it will be something like this. This is your original vector. Okay, this is your original vector where this is 4 I cap and this is 4 j cap. This is 4 I cap and this is 4 j cap. In that vector, you take a unit length, which is basically only this much. This is v hat. Then, if you show the components of it, this part will be 4 by 5 I cap. This much part will be 3 by 5 j cap. That is what it basically means. So if you go 4 by 5 I cap and 3 by 5 j cap, the length that you get will be exactly 1 unit. The length that you get will be exactly 1 unit along the direction of v. That is the meaning of finding the unity vector. Understood? Understood? Yes. Yes, Conqueror. Vipul sir is amazing. I have been with him for a very, very long time, even in COVID times. Yes, and I have met him. Sir is from Bombay. Amazing teacher, the way he interacts and has really cool animations in the class. Very nice teacher. Okay. Okay. Shall we go ahead? Shall we go ahead? Now, did you understand, my dear lions, how to do this kind of questions? So, we learned how to express any vector in IJK form. We learned how to find the magnitude, check whether it is unit vector or not. We also learned how to find the unit vector in that particular direction. Now, the final thing, the last way of adding vectors, and this is by far the easiest way. Imagine if I give you vector 1 is 2 I cap plus 5 j cap, and vector number 2 is minus I cap plus 3 j cap. Then if I want to find the resultant of them, v1 and v2, all I have to do is, don't have to use any unnecessary geometry formula, just add I with I, j with j, that's it. So 2 minus 1 will become 1, so 1 I cap. 5 plus 3 is basically 8, so 8 j cap. As simple as that. And by chance, if you want to find the subtraction v1 minus v2, so 2 minus minus 1 will make it 3. It will become 3. And 5 minus 3 will make it 2. So it will become 2j cap. That's it. Subtract or add the i's with I, j with j, k with k. It is that simple using the vector notation. That simple using the vector notation. So while you are adding, add the x with x, y with y, z with z. While subtraction, subtract x with x, y with y, z with z. So that's how you get the resultant vector, either addition or subtraction. Cool. Okay, so that was your final way. I think we can solve some more questions. Given a vector with another vector, if it is added, we get a unit vector along x. Then what is the value of b? Very simple. Think about it, how to solve this particular question. We have a vector which is given as I cap plus 2j cap minus 3k cap. We have to add another vector. I do not know what it is, but what I get is a resultant, and that resultant is a unit vector along x-axis. So other components are 0. That's what it means. Unit vector along x means basically I cap. So it is very obvious what the answer should be. Here, answer should be here the answer should be minus 2j cap, and here it should be plus 3k cap. So minus 2j cap plus 3k cap, if I add nothing over here, there should be nothing over here. So I will get only I cap, because 2 and minus 2, minus 3 and plus 3 will cancel. So I think the answer should be option number A. How many of you wrote option number A? Let me see. Very good, Luffy, Raja, Mesu, awesome. Keep spamming the answers. Very good, Gaguri. Awesome. Okay. So next question on your screen. Write the unit vector in the direction so and so. Write the unit vector in this. So A bar is given, find A hat. So A hat will be A divided by A. So A bar is 5i plus j minus 2k, whole thing divided by root of 5 square plus 1 square plus 2 square. So this will become 5 I cap plus j cap minus 2 k cap. What is this going to be? 25 plus 4 plus 1, that is root of 30, guys, root of 30. So hence the answer is 5 divided by root 30 I cap plus 1 by root 30 j cap minus 2 divided by root 30 k cap. So these are the components. If you add them together in 3 dimension, you will get the unit vector along the direction of A. Very good. Yep. Maran, I'm not taking any droppers batch right now for JEE, but if you are interested to learn under me, then you can continue learning on YouTube right now. Okay, this is our roar series. This is for JEE 25 and 2026. Obviously, droppers can watch these classes. Yep, yep. Okay. No, this is not maths class. This is proper your physics class. Cool. Shall we go now to the last part, which is multiplication of vectors? Remember, division of vectors was never defined. Addition, subtraction, yes. Multiplication, no. Now, when we talk about multiplication, there are three things. There are three things. One, multiplying a vector with a scalar. Second thing, multiplying a vector with a vector, but the output can be a scalar or a vector, depending how it is multiplied and where is it used. What is the application? I'll repeat, when you multiply the vectors, it is not as simple as 2 3s are 6. No, it depends what are you multiplying it with. Are you multiplying with just a number or with another vector? When you multiply it with another vector, the output can be a scalar, that is a pure number, or a new vector. So that's why the three categories. That's why there's three categories. Yes, Mesu, all the 22 books for 4,200 rupees for black and white. Color version is around 5,000 rupees. Correct. The link is there in the description. Now, what do I mean by that? First, let's understand multiplying a vector with a scalar. Imagine I write, imagine I write a vector, and now I write 5 times, or let's say 3 times a vector. 3 is a number, scalar, and a. So 3 is just nothing but a number, which is called as a scalar. So 3 times a means a, 3 times. That's it. That is 3a bar. Similarly, if I write minus 2a bar, minus 2 is a scalar. So minus 2 times means exactly opposite. So it will be like this. That's what multiplying a vector with a scalar does. In fact, if I say 3 I cap, what is I cap? Vector, 3 times. I cap, I cap, I cap. So this is 3 I cap. If I say this is vector B, okay, if this is, let's say, vector B, let's say this is vector B, this is vector B, and now I want to write, let's say, 2.5 times of vector B. 2.5 times means 1, 2, 0.5 times. So this will be 2.5 times of vector B. So that is what a vector multiplied with a scalar does. It gives me a vector of, different size, maybe in the same direction or in the opposite direction. So let me just put it up over here for all of you as a conclusion. One second, what just happened? Okay. So if I have B bar, or let's say A bar, and I multiply with a scalar, I will get, say, some k times of A bar, right? I will get a new vector. I will get a new vector, which is, let's say, B bar. So depending on the value of k, A and B can be in the same direction, opposite direction, and so many other things. For example, if the value of k is 1, or the value of k is positive, or the value of k is negative, or the value of k is -1, accordingly our answer will change. If k is 1, then A is B, so it will be basically your equal vectors. It will be basically equal vectors. If k is positive, That means you are multiplying it with a positive number, the direction will be same, those vectors will be parallel to each other. If k is negative, you are changing the direction, so it will be basically anti-parallel or opposite to each other, but need not be of the same length. If it is exactly -1, so you are creating a negative vector. You are basically creating a negative vector. So that's how the value of k decides whether you are in the same or opposite direction, equal or a negative vector, right? As simple as that. Yeah. Can we write 3a minus 2a and all that? Yes, why not? You can do all those things. Say for example, I have a vector a bar and I have another vector, let's say b bar. What if I write an equation like this? 2a bar plus 3b bar. Definitely you can write. So a bar 2 times, a bar, a bar. So this is basically 2a bar. B bar 3 times, B bar, B bar, B bar. So this is basically your 3B bar. So 2A bar plus 3B bar will be a vector like this using triangle law of vector addition. So that is your 2A bar plus 3B bar. Is that clear? Okay, that's how you can write it. You can multiply a vector with a scalar, multiply another vector with a scalar and add those vectors, subtract those vectors. It's completely up to you. Definitely you can do that. Yeah. So Shirish Reddy, you will be getting everything in the description box as you're watching this particular video, right? See, this Jungle Book is there. Click on the description box link, Jungle Book. It will open up. I have not logged in right now. So if you log in, you will get it. Okay. Fair enough. So I think this much part is clear. Everyone, this much part. Okay. How do you, multiply a vector with a scalar? Now let's go to the next part, which is multiplying a vector with a scalar or a vector. Sorry, multiplying a vector with a vector to get a scalar or a vector. So let's see the next part. So when you multiply a vector with another vector, depending on where you're using it, what are you trying to find out? Which formula are you applying? What is the physical quantity being found? Accordingly, the final outcome could be a scalar or it could be a vector. Okay. Now, if the outcome is a scalar, then it is called as a dot product because the symbol used is a dot. But if the outcome is a vector, the symbol used is a cross, and it is also called as vector product or cross product. The outcome is a vector product, is a vector, and it is called as a vector product or a cross product. I'll tell you why these things have come. Observe. See, work is the product of force and displacement. Force and displacement. Obviously, work is a scalar quantity. Obviously, work is a scalar quantity, but force is a vector, and this is also a vector quantity. Similarly, later on you will learn about a quantity called as a torque. Don't worry what is torque if you don't know it. And you will see it is nothing but the multiplication of that position with the force. Multiplication of the position with the force. Now we know position is a vector quantity. Force is also a vector quantity. And torque also happens to be a vector quantity. So the same force with a displacement gives scalar. The same force with a position, which is a vector, gives me another vector depending on context. Here we were trying to find work. Here we are trying to find torque. So where it is used, how it is used, what formula decides the outcome. You're going to be like, sir, how do I know that whether the outcome will be vector or scalar? So that is what I'm trying to tell. It depends on the context, formula, or the place or the application where it is used. So here, because vector into vector is a vector, I will use a cross symbol. Okay, that will be a vector. Here, vector into vector, I will use a dot symbol, which will give me a scalar, answer. Yeah. Is that clear, everyone? Is that clear, everyone? So dot is for scalar outcome, cross is for vector outcome. Now, please remember, in your school level, A dot B was the same as AB, which was also the same as A cross B. This was for scalars. But in vectors, A bar dot B bar is not the same as A bar B bar is not the same as A bar cross B bar. This is in vectors. This is definitely not same. In fact, out of them, this is not even valid. It is invalid to write. It is invalid to write two vectors without any symbol. There is no symbol in between. There is no symbol in between. You cannot write that like you used to do with x into y, xy, r square, ab. You can write all that. But in vectors, you cannot write it. You have to put a symbol in between because I don't know what the outcome is. So putting without the symbol means you are creating confusion. Is the answer vector or scalar? That is the reason why we put a symbol either dot or cross. Is that fine till this point? Clear? Okay, fair enough. Also remember, this is invalid. If I put I cap cross 2, not correct, or 5j cap is a vector, dot 6, it is invalid because the problem is this is a vector, this is a vector, these are vectors. But the problem is these numbers, they are scalars. So these both are definitely invalid. It is not correct only mathematically. You cannot do this. If there is a dot or a cross, both sides there should be vector. Like for example, this is okay. This is okay. Like 2i cap cross 3j cap. Nothing wrong. Perfect. Or 2i cap dot 3j cap. Perfectly fine. Nothing wrong because both sides you have vectors. Only one side scalar is not valid. This is wrong. Yes, Karthik, you can watch it. But don't worry, you have NEET content also, and I'll be doing these things soon on NEET as well. Okay. Everyone, till this point, all my lions. But in the formula of torque, force is perpendicular component. No, sir. Should we take J cap vector form? No, Shirish. Don't worry about forces that perpendicular and all that. That you will learn in rotation. Force and position can make any angle. You have to take the cross product of it. Doesn't matter. Okay. The force need not be perpendicular. It can be at any angle and still you can find the torque. Okay. So yes, that perpendicular component comes after you do the cross product. That is a secondary story. But okay, force and position can be taking any angle. Don't get confused there. Okay. Now, what are the rules? Because if you have dot product and cross product, there will be some rules, right? How do you find the magnitude of this versus how do you find the magnitude of this and all of that? So let me tell you very simply, for scalar product, what are the rules versus cross product, what are the rules? When you do dot product A dot B, the rule is very simple. You take the magnitude of first, magnitude of the second, and multiply it with the cos of the angle between them. As simple as that. As simple as that. Whereas in the vector product, if it is A cross B, then the magnitude of that vector, remember it's vector product cross, it is A first vector, second vector into sine of them, that's all. That's the only difference. If it is A dot B, it is AB cos theta magnitude. If it is A cross B, it is AB sine theta. It is AB sine theta. That is the magnitude of the vector product. Magnitude of the vector product is the magnitude of the dot product. Simple till this point? Okay. Now, in cross product, the main problem is the direction because, see, this is just the magnitude. What about the direction of A cross B? This is given by the right hand thumb rule. Right hand thumb rule. So what does this rule say? This rule says you take your right hand, everybody, take your right hand and point your fingers. And what you do? Point your 4 fingers in the direction of the first vector. In this case, let's say it is A vector. In this case, let's say it is A vector, which is the first vector. After the cross, which vector is there? B vector. So slowly turn your fingers curl your fingers in the direction so that they align towards B. So that they align towards B. If it is pointing towards A, slowly turn towards B. Slowly turn towards B. You will notice that your thumb is pointing in a peculiar direction. That thumb will point in the direction of A cross B. A cross B. That's how you find the direction of the vector product. Point it in the first vector, 4 fingers of your right hand, and then slowly turn it towards the second vector. The thumb points in the direction of the cross product of both of them. Is this clear? Now, interesting thing to note is the difference between their order of how you multiply. Meaning, if I do A dot B or if I do B dot A, it is one and the same thing. I'll get the same answer, meaning that they are commutative. They are just commutative. There is no problem in that. The order does not matter. The order in which you multiply does not matter. But here you will notice the moment I do B cross A, the moment I do, let's say for example, B cross A, what will happen is first you will take the 4 fingers in the direction of B, then to A. I cannot pull my 4 fingers like this. No, I can't take it like that. And this is a long way. If I have to go like this, it is long. So I have to turn my hand upside down, then point it in the direction of B, and then go towards A, I will see the thumb goes down. I will see that the thumb goes down. So my dear students, if I had to do B cross A, my fingers would be like this. Fingers would be like this. First pointing towards B, then slowly I will rotate it. Slowly I will rotate it so that they come in the direction of A, and then you will see this time along your thumb will be pointing downwards. Thumb will be pointing downwards, and that would be the direction of B cross A, which is exactly opposite as A cross B. So meaning that your B cross A is actually the negative of A cross B. Is actually the negative of A cross B. That means it is not commutative. It is not commutative. Magnitude is same, that's okay, but direction is not same. So as a whole, it is not same. So hence, it is not commutative. Is that clear? Is that clear, everyone? Everyone? Awesome, awesome. Shirish, please don't spam. Don't spam. Don't spam. If you spam like this, I will not answer. Okay? I will not answer. Generally, this is the thing. If students ask me 1 or 2 times, I'll answer. If you spam like 100 times, it is irritating. Don't do that. Don't do that. I can read the chat box. Till this point, is every student, every line understanding it? Okay. So now think about it. Think about it. Some of the interesting properties. Think about some interesting properties of dot product or scalar product versus cross product. If I do I vector dot I vector, what do you think I should get? What do you think I should get? Magnitude of I is 1. Magnitude of other one is also 1. And the angle between them is 0. So it will be 1 into 1 into 1, which is just 1. Same thing is true for everything. Same thing is true for everything, correct? So can I not like J and J also? So I dot I is the same as J dot J is the same as K dot K, which is just going to be 1. So the dot product is going to make the answer as 1. Very good. Electrostatics, Shirish, I will be starting this Friday. Optics, I will take it later on, but electrostatics Gauss law this Friday. So if I do the same thing over here, let us see. Can you guys guess? Quickly put it up in the chat box. I cross I or J cross J or K cross K. What do you think the answer should be? What do you think the answer should be? Let's try it out. If I do I cross I's magnitude is 1, I's magnitude is 1, angle between them is 0. So sine 0 is 0. Oh, it is just 0. So I cross I, which is same as J cross J, which is the same as K cross K, the answer is a big fat 0. So cross product of the same thing with the same thing gives me 0. Cross product of I with, sorry, dot product of I with I or J with J gives me the answer as 1. Gives me the answer as 1. You just saw that. How about I dot J vector? How about I dot J vector? Think about it. Interesting. I magnitude 1, J magnitude 1, the angle between them 90. Cos 90, 0. Oh, so the answer is 0. That means you take any two rectangular components, special vectors, unit vectors, J dot K or K dot I, doesn't matter. The answer is going to be always 0. It's always going to be 0. Okay, for dot product, because they are perpendicular. But over here, I think it's not going to be the case. I cross J magnitude wise will be 1 into 1 into sine 90, which is 1 into 1 into 1, which is 1. But direction wise, I cross J, let's try it out. First, put all your 4 fingers in the direction of the x-axis. In the direction of the x-axis. Then I cross J. Oh my God, you have to put your hand flat, not like this, flat, like this, as if you're holding something. So put your hand basically like this. And then slowly bend it over like this, because first it will be pointing in the direction of X, then it will be pointing in the direction of Y. You will notice that your thumb points over here. Your thumb points over here, which is basically your Z axis. Oh, so I cross J, magnitude wise is 1, direction wise is K, so it is 1 times K cap. So it is basically 1 K cap, which is the same as just K cap. 1 is because of this, so it is 1 K cap. But now this becomes so confusing that, sir, so many times I'll have to do my rotation of the right hand. It is so confusing. Is there an easy way to do this? The answer is yes. The answer is yes. So how do you do this without creating so much of trouble? Without creating so much of trouble. So let me just show that to you. 1 second. Yeah, it is simple, guys. What you do, write down I cap over here, J cap over here, and then K cap over here, like a clock, like a clock. 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 5 o'clock, like that. Okay, I, K, J, K. If you go clockwise, the answer is always positive. Whereas if you go anti-clock, against the clock, the answer is negative. Just keep this in mind. That's it. Now it becomes so simple to write down the answers. Observe how, if I write I cross J, I am going clockwise. The answer must be positive. If I go J cross K, the answer is going to be positive. K cross I, the answer will be positive, 100%. If I go J cross I, I'm going against the clock, the answer is negative. If I go I cross K, also the answer will be negative. If I go K cross J, also the answer will be negative. The answer will be negative. So now, what will come after the sign is the third alphabet. You got the sign? So I, J, which is remaining? K. J, K, I is remaining. K, I, J is remaining. J, I, K is remaining. K, J, I is there. I, K, J is remaining. That's all. That's how you're going to fill this up. This is so simple. Yes or no? Isn't this very simple? Isn't this very simple, my dear lions? Okay. So using this rule, it becomes very easy peasy, lemon squeegee. Okay. Going back now over here. Now, more properties, more properties. Interesting. If A vector is perpendicular to B vector, then what will happen is, if you take the dot product A dot B, it will be AB cos 90. Cos 90 is 0, so the answer will be 0. So the dot product is always 0. This is useful for solving many questions. This is useful for solving many questions. Example, I'll show you right over here. If 2i cap minus 3j cap is perpendicular to alpha I cap plus 4j cap, then what is the value of alpha? What is the value of alpha? Let's try to solve this. Because these two vectors are perpendicular, actually the dot product should be 0. The dot product should be 0. So what I will do, I'll just write it like this: 2i cap minus 3j cap dot product with alpha I cap plus 4j cap plus 4j cap. This answer should be 0 because they are perpendicular to each other. I put the symbol perpendicular. Now you multiply each term with every other term. Like for example, 2i cap with alpha I cap will be there, plus 2i cap uh, 2i cap with 4j cap will be there, plus minus 3j cap will be there with alpha I cap, and minus 3j cap with 4j cap. That answer is 0. Now I'll tell you what is the best part in this. Check this term out and check this term out. Both of them answer will be 0 because I with j or j with I, answer is always 0. I just told you over here. I with j or I with j or j with I or k with j or k with I, answer is always going to be 0. So hence they are perpendicular anyways, the answer is 0. So only this and this term is remaining. Only this and this term is remaining. So what is 2i cap into alpha I cap? It is basically 2 alpha, because I into I is 1. I into I is 1. Look at that. I cap into I cap is 1. So basically I cap went, so only 2 alpha is remaining. J cap into j cap is also 1, so I will just have minus 12. Minus 12 over here. Everybody understood till this point? Everybody understood till this point? Very good. So what will 2 alpha be? It will be 12. So what will alpha be equal to? It will be 6. So I found out this unknown quantity using this particular property. Using this particular property. Clear, everyone? Now, actually speaking, one second. Whenever you try to multiply a vector like this, dot product with another vector, let's say bx I cap plus by j cap plus bz k cap. You are taking the dot product. What will happen is you will multiply every single term with every single term, but some of the terms when multiplied, the answer will result into 0. Like for example, over here, if I multiply I cap with j cap or I cap with k cap, the answer is going to be 0 because they are perpendicular. Same thing, this j cap with this I cap or even this k cap, the answer is going to be 0. Even this k cap with this I cap or even this j cap, the answer is going to be 0. The answer is going to be 0. Oh, so what is remaining is basically only I cap multiplied by I cap works, j cap multiplied by j cap works, k cap multiplied by k cap works. Everything else, the answers will be basically zeros because I dot j, j dot k or k dot I, the answer is just a 0. That's why I cannot multiply it with anything else. So, my dear lions, what will be the final answer? Think about it. Ax I cap into bx I cap, won't it give me just ax bx? Ax into bx, I cap into I cap is 1. Plus ay into by into by, because j cap into j cap is 1, plus az into bz, because k cap into k cap is 1. So that is what you get when you do the dot product of two things. A very good example of this can be this particular question. Example, work is force dot displacement. The force is given to be 2i cap minus 3j cap plus k cap, and the displacement is given to be 4i cap plus j cap plus 3k cap. Question is find the work. Question is find the work. Let's try to solve this using our same technique as mentioned over here. As mentioned over here. I'm just taking the dot product of two vectors. I'm just taking the dot product of two vectors. Now over here, I will only multiply with I. So technically just multiply 2 with 4. Just multiply this 2 with this 4. That's it. Then don't put I cap, because I cap into I cap is 1, plus minus 3 into plus 1, minus 3 into plus 1, plus this thing k cap and 3k cap. So 1 into 3. That's all, guys. 2 fours are 8. This is minus 3. This is plus 3. Wow, perfect. So the answer is 8. So the answer is going to be 8. As simple as that. So it can be used in finding out the final answer of some physical quantities, like work is force dot displacement, power is force dot velocity, flux is field dot area vector. So many places you will use this particular scalar product or dot product, okay, which is based on this particular thing. So you have seen scalar product can be found. Scalar product can be found using this formula, and there are simple rules over there, like one mentioned here. Also keep in mind that while using scalar product, you can also use this opening of bracket rule, meaning a plus b dot c is actually a dot c plus b dot c. So you can open up the brackets. This is your distributive law. Distributive law is obeyed. You can open up the brackets as over here. The same thing is also valid even for your vector product, by the way. The same thing is also valid for your vector product. So I can just put it over here. So if I have a plus b cross c, keep the same order. Do not mismatch the order. So it will be a cross c plus b cross c. That's it. So this distributive law is obeyed. Distributive law is definitely obeyed. There is no problem in that. You might ask, sir, are there some other uses of dot product? One use I saw, sir, like using this particular example, you could find quantities like work, etc. Another use I saw, I can find if two vectors are perpendicular or not. Let me tell you, there are even more uses. There are even more uses of dot product or scalar product. One such use is to find the angle between two vectors. To find the angle between two vectors. How do you find the angle between two vectors using dot product? Very straightforward. Observe this simple derivation. A bar dot B bar is A into B into cos theta. Just take A and B below. So it will become cos theta is equal to A dot B, the whole thing divided by AB. So what is A dot B? You can use this AX BX plus AY BY plus AZ BZ and all of that. And what is A and B? A is basically your root of AX square plus AY square plus AZ square. And what is B? B is basically BX square plus BY square plus BZ square. That's it. Using this, you can easily figure out the angle between any two vectors. Angle between any two vectors. I've just substituted each one of them over here for you. So it looks very big, but actually it is very simple, like you will see in this numerical. Example, if A is 2i cap plus j cap minus k cap, and B vector is I cap minus j cap plus 2k cap. Okay. find the angle between A and B. That is your question. Find the angle between A vector and B vector. These are vectors in 3 dimensions. You don't even have to visualize anything. You just have to go with the formula. You just have to go with the formula. How? Observe. So, to find the angle, the formula is cos theta is A dot B divided by AB. Let's find A dot B separate, A separate, B separate, and then substitute. Then it will be very easy. So, what is A vector dot B vector? I cap multiplies with I cap. So, 2 into 1, that is AX BX, plus AY BY. So, it is 1 into minus 1 plus minus 1 into plus 2, minus 1 into plus 2. So, this will become 2 minus 1 minus 2, which is going to be minus 1. Just check this out. Is A dot B negative 1? Is A dot B negative 1? Everyone with me on this? Awesome, my warriors. Now, what is the value of A? Think about it. It is root of 2 square plus 1 square plus minus 1 square, which will give me 4 plus 1, which is root of 6. What is B? B is going to be 1 square plus negative 1 square, which is same as 1 square, plus 2 square, which is again going to be root of 6. Perfect. So let's substitute it over here. A dot B was negative 1. A is root 6. B is root 6. So this will be minus 1 by 6. So theta will be cos inverse of negative 1 by 6. Just leave it as it is. Just leave it as it is. That's it. You don't have to do anything more. Is that clear? Is that clear, everyone? Shall we go ahead? How do we find angle between two vectors? Okay, this is the formula and I just showed you a sample problem over here. There is one last use. There is one last use of scalar product, and that is to find component of a vector along other vector. See, I'll tell you what it means. If you had a vector v and this was, let's say, your x-axis, then you used to say this part is the vector v's x component. Vector v's x component, meaning you used to drop a perpendicular, this 90 degree, this is the x component of v, correct? Along the x-axis. But what if the direction is only something else? Example, imagine there is a vector v and there is some random other vector a, and I want to find the component v along a. So basically I'm dropping a perpendicular like this. This becomes v's component. This becomes your v's component along a. This is your component of v, component of v along which vector? Along basically vector a, along a. That is what it means. Component of some vector along other vector. It's not that difficult to find. I'll tell you how. Because let's say if I mark this angle as theta, if I mark this particular angle as theta, then I think we can find it out easily, because cos theta is adjacent side by your hypotenuse, which is v. And what we can also do is VA is V cos theta. So cos theta we know from our dot product rule, which we learned over here. Cos theta is A dot B by AB. So same thing if I apply over here, it will be V bar dot A bar upon VA. V bar dot A bar upon VA. V will cancel. So it will become V bar dot A bar by A. Rewriting it like this, V bar dot A bar by A. What is this A bar by A? Come on guys, you know this already. It is A cap. It is basically A cap. So hence I have found the answer. Hence I have found the answer. The component of any vector along any other vector is V, that vector dot the unit vector along which you want to find. The unit vector along which you want to find the component. So this is the formula. This is the formula. Is that okay, everyone? With me on this? Shall we take up a simple problem on this so that you understand how this has to be done? Let's take. Imagine the vector that we are talking about is 2 cap minus 4 cap. Okay, 4 cap. And the vector along which we want to find the component is let's say 6 cap plus 8 cap. Let's say 6 cap plus 8 cap. The question is find the component of V along A. Question is find the component of V along A. Just application of this formula. So we know V along A is V vector dot A cap. So let's find what is A cap first. Without that, we cannot proceed ahead. What is A cap? It is vector divided by magnitude, unit vector along any direction. I just told you some time back. That vector is basically 6 cap plus 8 cap. The magnitude of that vector is 6 square plus 8 square under the root, which is 10. So it will be 6 by 10 I cap plus 8 by 10 j cap, which is 3 by 5 I cap plus 4 by 5 j cap. So that is your A hat. So I'll multiply it over here. So dot product 3 by 5 I cap plus 4 by 5 j cap, and V vector is as it is. So 2 I cap minus 4 j cap. I cap will only multiply with I cap. So 2 into 3, which is 6 divided by 5, minus 4 into 4, which is 16, 16 divided by 5. 6 minus 16 is basically minus 10, which is minus 2. So basically, the magnitude of the component is more important. So the magnitude of that component is basically 2 units. Yes. With the sign, it was negative. Negative means it is just in the opposite direction. That's all. Don't worry about the minus sign. But other than that, it is just saying the magnitude of that projection, that perpendicular which I have drawn, is 2 units. Minus 2 means it is in the opposite direction. That's all. So don't worry about the negative sign. So these are the applications of dot product. So let's see some questions. I have also posted all these things, finding the angle between the two vectors and all that. It's already done. So I don't want to repeat those slides. Okay, even this one. Okay, so let's see some questions based on this. If A is this, B is this, find the angle between A and B. Come on, let's try to do this question. Find the angle between these two vectors. Very straightforward question, guys. So we have to do basically cos theta is A dot B divided by A into B. What is A dot B? Mentally only you can do it. I cap with I cap. So 2 into basically 4 plus J cap with J cap. So 3 into 3 plus 4 and 2, k cap into k cap. So 4 into 2. The whole thing divided by A is the magnitude of vector A, which is root of 2 square plus 3 square plus 4 square. Whole thing unto 4 square plus 3 square into 2 square. Come on, my dear students, what is it coming out to be? This is basically 8 plus 9 plus 8, whole thing divided by root of 3 square plus 4 square, that's 25. 25 plus 4, that's 29. And this is again same thing, 29 only. So what is this? 8 plus 8, 16 plus 8, 24, 25. So 25 by 29. So hence theta will be cos inverse of 25 by 29. Just check this out. Cos inverse of 25 by 29. Very good, Divakar. Adiksha, so many of you got it correct. Excellent. Can we use sine theta? No, Mesu. Why will we use sine theta? Because we are using dot product. If you are using dot product, you have to use cos theta only. Because remember, that was the derivation. I just derived this formula just for you, right? I derived this formula because that comes from the definition of A dot B. A dot B has been defined using cos theta. Next question coming up on your screen. If A and B are this, which of the following are correct? Which of the following are going to be correct? Very interesting question. Come on, my dear students. See what the answer for this is. This is level 3 question. This is level 3 question. Everyone, figure this bit out. Figure this bit out. Come on. Come on. First option says A and B are mutually perpendicular. Is that so? Let's try it out. Let's find what is A dot B. Just find what is A dot B. A dot B will be 5 into 6. 5 into 6 plus minus 2 and plus 6. So 6 into minus 2 plus minus 6 into 3. Minus 6 into 3. What is this? 30 minus 12 minus 18. Oh, that is 0. Oh, this means A vector is perpendicular to B vector. 100%. 100% A vector and B vector are perpendicular to each other. Product of A and B and A are same. This is 100% wrong because it is never commutative. It is never commutative. So A cross B will never be the same as B cross A. I just told you this. Magnitude of A and B are equal. 6, 2, 6, 5, 6, 3. No, yaar. Come on. You can just try it out for yourself. A's magnitude will be root of 5 square plus 6 square plus 3 square. B's magnitude will be root of 6 square plus 2 square plus 6 square. Obviously, they are not equal. Obviously, they are not equal. So this is also wrong. Magnitude of A dot B is 0. We just figured it out. Hence, that's why they were perpendicular. So I think it is answer A and D. Let's see whether it is correct. Yep, answer A and D. Answer is A and D. B, C will be wrong. How many of you got A and D correct? Let me see. How many of you got A and D correct? Very good, very good. So many of you got it correct. Proud of all of you. Proud of all of you. Level 3 question. Awesome. This is another level 2 or level 3 only. This should be component of one vector along another vector. So you should be very careful over here when you're finding the component of one thing along another thing. Who is V? Who is A? This is basically V. This is basically A. So component of V along A is V bar dot A cap. So first find out A cap. A cap is A bar by A. So it is I cap plus J cap. Magnitude is 1 square plus 1 square. So it will be 1 by root 2 I cap, 1 by root 2 J cap. So substitute it back over here. So I cap by root 2, J cap by root 2. V vector is 3I plus 4J. So let's see what happens. 3 into this will become 3 by root 2. 4 into this will become 4 by root 2. So this will become 7 by root 2. So that is the component of this vector along another vector. So 7 by root 2. Very good, Divakar. You guys are very quick and proud of you. Yes, yes. What is your doubt? You can post it. When will you start second year syllabus, sir? When will you start second year syllabus, sir? Okay. See this. I'll show this to you. On the channel, do you see upcoming streams? What is this? Which topic is this? Electrostatics, field and potential is scheduled on this Friday. Okay. So yes, your second year syllabus is starting. Okay. This week only. We'll continue with this also in Gauss's law. And we'll be taking up more or less parallel things 11, 12, 11, 12 so that we cover as much syllabus as possible in the limited time that we have. Cool? All right. All right. Perfect. Moving on to the next one. Okay, so let's go to vector product. We had seen some rules basically. Let's continue from here onwards only. Now, the main problem happens. The main problem happens when you have to find the cross product of two random vectors which are weird, which have very random values. So that's when the main issue happens. I'll show that also to you. Before that, going ahead, let me also tell you one important thing. When two vectors are parallel or anti-parallel, when two vectors are parallel or anti-parallel, meaning like this, or like this and like this, then what happens if you take A cross B? If you take A cross B, what do you think you will get? You will get A into B magnitude wise, A into B sine 0 or basically sine of 180. Sine 0 or sine 180, both the answers are 0, hence the answer is always going to be 0. So whenever the vectors are parallel or anti-parallel, you will see their cross product will be 0. But more than that, I feel you should remember that whenever the vectors are parallel or anti-parallel, then that vector B, because it is parallel or anti-parallel, will be some scalar number of times of A. It will be some scalar number of times of A. Correct. If it is positive, it is parallel. If it is negative, it is basically anti-parallel. As simple as that. You don't even have to use the cross product because finding the cross product is generally a tedious task. Let me explain this to you with an example. If the vectors A and B are parallel to each other, what do you think is the magnitude of the vector B? What do you think is the magnitude of the vector B? Okay, let's see if you guys can figure this out. First of all, it is clearly mentioned that A vector is parallel to B vector. So, all the vectors components will be multiples of each other. If you notice, what should happen is magnitude of, or rather B vector will be some k times of A vector. So B vector, let's say if it is 5 I cap minus P j cap, this should be equal to k times of 2 I cap plus 4 j cap. So we can in fact find this k, it is not that difficult. You can see it is 2k I cap plus 4k j cap. Now compare left hand side with right hand side. Compare left hand side with right hand side, you will immediately understand what has to be done. Come on, compare. This is 5 I cap, this is 2k I cap, this is minus p, this is plus 4k. So my dear students, do you see, if you compare this with this, obviously 5 should be equal to 2k, or rather k will be equal to 2.5. K will be equal to 2.5. We can even find the value of p if you want. This unknown p which is there, we can find it out. So minus p will be equal to 4 times of k. So k is basically 2.5. 4 times of 2.5 is 10. So p will be basically negative 10. So we can find the value of p also. So we know the value of p, we know the value of 5, x component. So to find the magnitude, in order to find the magnitude of b, just take the x component, just take the y component, square it, put it under the root, you have got the answer. So 25 plus 100, which is 125, which is 25 into 5, which is 5 root 5, which is option number A, which is option number A. Is that clear, my dear students? Is that clear, my dear students? Understood? Very good. Good evening. Good evening, everyone. Next important application is to find out different physical quantities. In fact, like for example, you will see torque will be R cross F, or angular momentum will be R cross, momentum, or the magnetic force will be charge into velocity cross B. And so many more physical quantities are there which depend on the cross product. But how do you find out the cross product of anything? That is what I'm going to explain to you over here. Say, for example, you have to find 2 I cap plus j cap minus k cap, cross it with 3 I cap plus 2 j cap plus k cap. I want to find this out. Something cross something, what is the outcome? The rule is just like determinants and matrices, how you open them up, same way you do the multiplication. Now, some of you might have learned matrices and determinants, so you might know it. If you don't know, don't worry, I'm going to teach it to you. Very straightforward. What you do is, whenever you find this kind of problem, the first step, I'll start duplicating so that you can see step-by-step procedure. First step is put up, first step is put up I cap, then put j cap, leave some space and put k cap. Okay, put this up. The next thing that you're going to do is below them, write down the respective coefficient in the same order. This is the first vector, this is the second vector. So the first vector, that is basically 2, then j has 1, k has -1. The next one, 3, 2 and 1. That's it. That is what you're going to put. Just put down the respective coefficients or the components, positive, negative, according to the sign. What is the next step? The next step after this is this important thing. Put I cap over here, put some brackets, then definitely put negative j cap over here because that's how determinants are expanded, and then put another bracket over here and then put k cap over here. Okay, I cap, negative j cap plus k cap with some brackets. That's your next step. After this, what you do? For finding I cap, forget this and forget this. Just concentrate only on these 4 numbers and go like this. The manner in which you will go is like this. Multiply the cross elements and then subtract them. 1 into 1 are the cross elements, 1 into 1. So 1 into 1 minus 1 into 2. Minus 1 into 2. Same way, next step over here. While finding j, forget this, forget this. Just concentrate on these two and these two. Cross them and then subtract them. 2 into 1 minus 1 into 3. Last one for k, forget these columns and rows, only concentrate on the remaining rows and columns. 2 into 2, 1 into 3. So 2 into 2 minus 1 into 3. That is what you're going to do. Is this clear till this point? Now you just find out the value. That is the final answer, my dear students. So this will be plus only. So 2 plus 1, right? So this will be 2 plus 1. Let's see how many of you wrote down 3 I cap first. How many of you wrote down 3 I cap first? Very good. Many of you wrote it down. Next one. This is 3 plus 2. That is going to make it 5. Yep. Let me see how many of you wrote minus 5 J cap. Very nice. Very nice. This is 2 minus 3, which is minus k. Minus 1. Sorry. Minus 1. Yep. Perfect. So this is minus 1. So hence the final answer is 3 I cap minus 5 j cap minus k cap. Not plus k cap, minus k cap. Some of you write plus k cap. Just check this out. It should be minus k cap, guys. Oh, sorry, plus only. My bad. It was not minus 1. 2 2s are 4. 2 2s are 4 minus 3. My bad. It was plus only. My bad. Yeah, plus. Yeah. That's all. So this is how you're going to do the vector multiplication. I'll again explain the steps right from the step 1. Whenever you have to do, whenever you have to do vector multiplication of two vectors, first thing, put ijk, below that put their components down, then put I cap, minus j cap and k cap with the brackets, then go in this style, just like how your teacher gives you wrong, right? Wrong, correct and wrong. Same way, like this. Cross is multiplied and then subtract. So for I cap, forget those columns and rows, 1 into 1 minus 1 into 2. Then like that. Do it for other elements also. Solve it and you will get the answer. Straightforward. This is another important role of cross product. This is another important role of cross product, okay, which I have told you. Later on, you will study that there are other applications also of cross product in your chapter of vectors. So all these things we have done. Where did it go? Okay, so this is done. So I think we should solve some questions now. Let's see if you guys can solve this. If a vector points vertically up and B points north, the vector A cross B is along which direction? If vector A points vertically up, this is A, and B points towards the north. North is basically inside. North is basically inside, guys. Just try to visualize this. North is basically inside. So if you look at it from the axis point of view, this was your Z axis, this was your Y axis, and this was your X axis. This was Z, this was X, and this is Y. So A is along basically I cap, B is along minus K cap. So what will I cross minus K be equal to? Remember that cyclic order which I had told you, I, J and K? Okay, do that. I cross K. So if you do I cross K, it is anti-clockwise, so it should be negative. So I cross K should be negative, but this minus sign is also there. So one more negative. And I and K, what is remaining? J. So J will be remaining. So it will be along J cap. Now what is J? J is, oops, what did I just do? I'm so sorry. I'm so sorry, guys. What did I just do? My bad. Sorry. Here is upwards. So this is not I cap, this is J cap. Sorry, happens. This is J cap. My bad. Okay. This is J cap. And vector B points towards the north. North is, let's say, like that. If you're standing like this, up, down, east, west, front is north, back is west. South. So you're basically trying to find J cross minus K cap. Now J cross K, remember that rule, I, J and K. So J cross K, you're going clockwise, so it should be positive. So only that negative sign will come from here and the answer will be minus I cap. What is minus I cap? What is minus I cap? Come on, my dear students. What is this minus I cap? Minus I cap means it is here. This is minus I cap. Which direction is this? This is going to be west direction. So along the west should be the answer. Along the west should be the answer. Yep, very good. Is that clear? Awesomeness. Next question on your screen. Can you check if A cross B and A dot B will be equal or not? If A and B both are not 0, what if one of the two vectors is 0? Interesting question. If you answer this, I am really, really happy. Is it possible A dot B and A cross B are equal without A and B being, 0? And actually, one is a vector, one is a scalar. Technically, there should have been a modulus sign, or else I can't equate them. So let's say this modulus is there, then only it makes sense. Okay? Or else, how can you equate a vector with a scalar? That is not valid. Please remember, A cross B is never ever going to be equal to A dot B no matter what you do, because on one side this is a vector and a vector can never ever be equal to a scalar. You can't equate 5 oranges is equal to 5 apples. Not valid. Even though the number 5 is there, the type is different. Okay. So, my dear students, my dear lions, what do we do? A cross B's magnitude is A, B sine 45. A dot B. A dot B is A, B cos 45. AB cancels. Only then you will see they will be equal. Otherwise, they will not be equal. Forget 45. Why did I know 45 is because I know sine 45 and cos 45 are equal. Forget that. Even if I put theta, sine theta will be equal to cos theta. So theta will be 45 degrees. Theta will be 45 degrees. So only then you will see that their magnitudes of cross products are equal. Exactly. Perfect. Okay. What if one of the two vectors is 0? Well, the second part, imagine A cross B magnitude is 0 into B into some sine theta. Theta is not 45. And let's say A dot B, A dot B's magnitude will be 0 dot B into cos theta, This answer will be 0. Even this answer will be 0. Why? Because one of the vectors is 0. If one of the two vectors is 0, the final outcome is also 0. Hence, both of them will be equal. Yes. What if one of the two vectors is 0? Then it is equal. Then our final conclusion is, then they are equal anyways. Doesn't matter. If one of the two vectors is 0, 0 into anything is 0, 0 is equal to 0. So this will be equal to this. Doesn't matter what that angle is. Always. Perfect. Moving on to the next one. We have seen these applications. We have seen this. We have seen this. Okay. Let's see if you can solve this. Two vectors A and B are inclined to each other at some angle. What is the vector perpendicular to A and B both? Very straightforward. What is the unit vector perpendicular to A and B both? Come on. Very, very simple. You have a vector A, you have a vector B. I want a unit vector which is perpendicular to both of them. Perpendicular to both of them. It has to be like this. This is only possible, remember, if I do A cross B will be the only vector which is perpendicular to both A also and B also. And I want a unit vector in that direction. So this unit vector, if I call it U prime, or sorry, U hat, this U hat will be nothing but A cross B. A cross B. That is the whole vector divided by A cross B's magnitude. A cross B's magnitude. So it will be A cross B. A cross B's magnitude is AB sine theta. A cross B divided by AB sine theta. That is option C. Not cos. This is not correct, guys. This is something else only. Okay. So, oh, actually, even that will work. Actually, even that will work. I'll tell you why. I'll tell you why, because I can write this as A cross by A bar by A cross B bar by B, and I have basically 1 by sine theta over here. This is basically A hat. This is nothing but B hat, and I'm just dividing it with sine theta. So even this is true. Even this is true. But this is not true. This is not true. This is not true. This is not true. So multiple answers are correct in this. Even this and this. Both are correct. How many of you wrote B and C? None of you wrote B and C. Everybody just said C. That is wrong. That is wrong. Okay. So even B is correct. Be careful. I think this is one of the last few questions. Torque is asked if R and F are given. And remember, the torque formula I just told you is R into F. Is R into F. Come on, my dear lions. Figure this bit out. Yes, it was not just Captain Shreyas. Something more than Captain Shreyas was also there. Something more than Captain Shreyas. Come on, come on, come on, come on, come on, my dear lions. Figure this bit out. What did I just tell you? Go step by step. First put I, then put J, then put K. Put the numbers 731, 731. Then force -3, 1 and 5. Okay, that is done. Then put a line nicely. Put I cap, then put minus J cap, and then put K cap. Perfect. Next thing. For I cap, forget this, 3 5s are 15. So 15 minus 1 1s are 1. For J cap, 7 5s are 35. 1 into -3 is -3. So -3, right? For J cap. For K cap, 7 1s are 7. Minus 3 3s are 9 with negative sign. So -9. So this will become 14 I cap. 35 plus 3 is 38 with negative sign. So -38 J cap, right? 14 I cap, 38 J cap, and -38 J cap. And then this is basically plus you're basically 16 K cap. Perfect. So this is the final value of the torque. I think that answer is there as option number A. Perfect. Option number A is correct. Very good. So that's it for today. In this particular class, we have completed vectors as a whole. We have seen multiplications. We have seen all the kinds of multiplications and their applications. We have seen how to add vectors, how to play with vectors. We have seen how to subtract the vectors geometrically, analytically, what is the component, what is that unit notation and all of it. As you watch this lecture, also remember that the next class is going to happen on electrostatics. This is a roar series, one shot, proper mains plus advanced with level wise, and even in the description box you are going to find the PDF of the notes, DPP, everything over here. Just click on this particular link. Okay, it will open up everything. If you're interested to buy the books, use this particular link to buy the Tatva books. Okay, it's available, the set of 22 books with problems, PYQs, advanced material, notes, QR codes, concept videos. Yes, videos are there in this book to explain the concepts. You can scan the QR code and use it. Everything is a part of this. Okay, so use that. I feel that will be the best solution as you are learning from YouTube. Okay, and as you watch this video, also like and comment below this video how much you enjoyed this particular lesson, and are you confident now about this class? Are you now waiting for the next class? Are you now enjoying learning with this particular channel with me, your Captain Shreyas, right? Thank you so much, my dear lions. Take care, have a great time, have your dinner. Even I'm going to have my dinner. Bye bye, take care, hasta la vista.